this program of the DevOps track, I can say, or plus the Git also, right? So last 2 days, around almost 8 hours, we have discussed multiple core thing about Git, or I can say GitHub, right? That was just a core. I'm not saying basic, but it's a core because the way I explained to you how Git work behind the scene. What is the meaning of the working area? What is the meaning of the staging area and the commit area, right? And the interesting thing is I explain you the core idea behind it, right? The way they take the snapshots, the way they keep on doing commits just to maintaining the versioning so we can control the versions, right? Or so that we can also track, because as a mostly this tool is mostly used by the developers, right? And when I say developers, it doesn't mean the pure software developers, right? Of C++ or Java language or Scala language. Nowadays, whichever the domain you go, right? We have to write the code. Maybe you are from the IT admin background, right? You have to write a shell scripting or some kind of scripting, or maybe you are from the DevOps world, right? From Kubernetes to Ansible, almost everywhere we have to write some kind of code in certain language. They might be markup language, but certain code we have. So because today we are moving towards the toward the automation, right? This is one of the key idea behind DevOps. Okay, so in the automation world, the things that can only be automated only if you can write the things into the code, because without the code, thing won't be automated. This is the very simple statement. Okay, now the interesting point over here is it means whatever you want to achieve, you have to write the code, and whenever you write the code, it look like you are a developer, and it's when it look like you are the developer. So the idea of the code is you write something, then you implement, then you write something, then implement something what you have already written in the code. um, that portion you might have changed, some bug come up, some security loophole come up, some new features come up. So it is like a lifelong, or if you talk about the life cycle, I can say, of the software development, it will be like a infinity, right? It's till the time your project goes, or till the time your company goes, right? You have to keep on changing and updating things in your code, in your program, in your software, whatever you say here. Okay, but but we don't know what are changes we do, it will crash my system. We don't know. Okay, or what are changes we do in the future, maybe my client doesn't like that change to whom you are writing the code for, right? So you might have to come back. This called rollback. Okay, so those things you can do very easily if you have somebody who track you. Okay, then today you have done this, tomorrow you are going to do this, or maybe last 2 days or 3 days back, this is what the activity you guys have done, right? So if you don't have any tracking system, right, it is very harder, or I can say is impossible to go back, because it's not like there was just some limited lines of code you are writing. It is like huge code of hundreds of pages connect together. Every page have thousands of lines you're going to write. Multiple teams also working, right? So you also need some tool where you can manage your source code. Okay, so management of your source code in XYZ language, whatever guys language you know, from Go to Ruby to Perl, Python, or to any other DevOps language, or maybe markup languages. So you should know how to manage your code, especially in the team, how you guys can work together, collaborate, and work together, right? There's also one big area. So this called that is a reason this area is known as SCM, source code management. How you're going to manage your code. When I say management, it takes everything in management. It is version control systems also come up, how the team guys work together, and some more thing also come up, right? So today, okay, Saturday and tomorrow, Sunday, again, we are just in the mid of this training. So, but in this around 8 hours, this class is to be very advanced, lots of advanced topics we are going to discuss. We are going to talk about multiple merge strategies, merge conflict in different way. Squashing is very powerful thing. Ref log, we have to use a lot. Research, different kind of research. We have hard, soft, and mixed. We are going to discuss stash is one powerful concept. Cherry picking is one concept, and much more. Okay, amend if you want to do something like this. So like this, or in a GitHub perspective, how different kind of syncing or my main point here is these are some options in the GitHub. If I take those options and the topics that I'm talking about right now, maybe it takes half an hour to show you all those command, all the options. For example, squash option or rebase option. Okay, so very quickly I can show you the commands and the output. But the interesting thing is in the Git is every options or the strategy is been solving some kind of use cases. Okay, so if you don't understand what is the challenges we are facing in some particular area or some particular scenario, if you don't understand that particular use case, then only we can implement, we can take a particular command of the Git and take particular strategy of the Git, what Git is offering. So my point here is we are going more deep, more advanced, and trying to take almost all the main and major use cases or challenges what normally we face or you guys are facing or you will face in the future, and how we can resolve those challenges, and what kind of strategy or what kind of tooling from the Git we are going to use, right? So that might be one of the reasons why it takes 8 hours for me around 8 hours for me now from now to show you this entire further topics, right? So whatever guys we have in the agenda, we are going to cover the remaining portion, plus whatever I have some more concept that might not be there in the agenda, but we also cover those things also, right? So I think very clear. But as we progress in this course, you guys come to know. So without wasting further time, what I'm going to do, I am going to let me share my screen first. Okay, 1 minute. 1 minute. So what I'm doing right now, because I'll quickly revise some of the very common things what we have done in the last class, right? In a very different way. I'm going to introduce guys one very beautiful tool to just that tool is very fantastic for learning the Git in the better way. Okay, by some kind of visuals. They give you some visuals and they show you what is happening behind the scene, right? And that's one thing. So I'll just going to introduce this tool to you. It's a good way to debug if something is not working, if you fail to understand why thing is not working the way we want. Plus it also give us visuals that help to understand the tool very and the concept in very better in more better way. Okay, so let's introduce tool. Before this tool, very quickly I want to summarize one small thing. Okay, the thing is, wherever you guys work, always we work in a file. In a file we write a code, and this the file or multiple files we put in a folder. That folder is called working space or workspace. It's also known as work area or working area. Okay, now if you think you want to take a copy of this work till now, okay, that you guys know is called snapshot, and here technically is known as I want to commit, and whenever you commit they give some area space to that data, whatever you're committing that point in time. Commit is like a copy of something that point in time. It's called point in time backup concept. I already explained to you. And that those time they give a ID is called commit ID. So this is called commit area. But the concept is you can't put the data directly on the commit area. You have to first put those data or those file in the staging area. When I say we have to put, it doesn't mean you have to copy the data here. Uh, Putting the thing in the staging area means we just inform or to the staging area that we have some multiple files or multiple lines of code. I want to put those things, their information over here. That this 10 file I want to put in you, and those 10 files, these are the data I want to put on you. Means I just want to just take this information, take this reference, this that is called metadata. So in the future, whenever you commit all data in the staging area, we can copy here. Or all the information of the staging area that is typically known as reference. Okay, they maintain. And guys, you guys know whenever you want to store any information, for example, you might have book of 1,000 pages, right? But every pages have some data, some information, but you want to store the entire book information. The initial page of the book is enough, right? So in the initial page, what you see, you see the TOC content, table content, right? And in the table content, we write chapter number 1, this is the data you will find. Chapter number 2, this is the data you will find. So so my point over here is this: the first page is normally known as index page, and what this index page contain only the information about what you have in this book, where you find, which page you find, what chapter name. So they put some summary. That summary or that page of your book, of any book I can say, is also known as index. So typically staging area is work like an index. They know the reference. Reference means they know in the working area where this file located, what is the file name, okay, which lines of the file has been changed, what is the location of those lines. So they maintain this information, that's called index. Okay, and how they're maintaining, with the help of referencing of the concept. So anybody who know about any programming language, they might know, reference concept normally we use in the functions, right? If you know, otherwise there's no technical requirement to know here. So these information behind the scene guys store in the staging area. So just guys, I was trying to summarize what we have done in the last class, right? But when we are working on Git, you might not require some time to know all those stuff, right? But it's good to know if you know what is happening and what the use of what area. So something fail and you have to troubleshoot, and in troubleshooting perspective, if you know much more deep, better you would be troubleshoot the issues if you face. And normally we will face multiple issues time to time. Okay, this is one thing. Now, second thing is, whenever you commit, this is the first commit created, and I am also using one more term. So instead I say commit, first commit created, let me use the term #1, first commit created, or or it is also known as version. So version 1 created, whatever name you want to give, you can give. And this commit is what? It's just like a snapshot, just like a backup of that point in time. Okay, of that point in time. This is what they do. One minute, guys, please. Guys, I believe my screen is not properly visible. That's my team give feedback to me. I'm again resharing my screen. If you guys can help me out. Now, is this coming clean? Is okay, right? Okay. So my screen is entirely visible, right? Yes. Thank you very much. So this is one commit area. Then you commit one more time, you do more changes in your working area. Again, you put in the staging area, and then you commit one more time. Again, I'm very excited for today's class. I'm just quickly revising this point so that you can reference back and you can connect those pieces what we have done in the last classes in the today's class. So I'm doing a little faster comparatively, I can say, what we discussed in the last class, so I can jump very quickly on and today in today's topic. Okay, so there's commit 2, and let's say this is the version 2 we have created. Whatever the change we have this point in time is called point in time backup we store here. And let's say, let me write one more time. We have one more commit we created. Let's say the commit number 3. Let's say this is version 3 we created. But this entire, you can say this is one kind of timeline, or this entire timeline, right, is stored in one, or I can say this entire timeline we can give a name, right, to for the management perspective. And this timeline we can give, let's say, the name called master. But instead we normally use the word timeline here. We normally use the word called branch. So I can say in this branch, what are the name would be master or developer one or your name, right? In this branch, we have done 3-time commit at this point in time. And who have done this, we also maintain the author name and other things also. Okay. And why we need a branch or timeline? That's what I guess explained in my last class. Multiple branch we create, there is feature branch to add some more things and something like this. So something we have discussed in my last class, but we go more deep into the branching topic and the merging topic. Okay, so there's one branch, but the very important point, guys, to note here, that is why I again explain this concept very quickly here, is whenever you create a branch, okay, without branching it is impossible to commit. Means every commit is stored in your branch, whatever the name would be, master or dev one branch, whatever you say. Okay, but the important point is, okay, whenever you commit, okay, when you commit the last commit, we maintain this information in one special variable that's called head variable. So what are the last commit would be, head is a special kind of tag, I can say, even though I can say reference, or that know, or this variable know that commit number 3 or whatever their complete ID is the one who is the last commit. Okay, why is very important to know? Because whenever you right now, guys, you are into Git. Guys, the concept I'm going to explain, you just try to understand very clearly, very important concept. Okay, right now you want to Git, maybe you're working on your local system. Okay, in a Git, local Git. Okay, and your plan is to sync your data on the cloud, let's say in the GitHub. And what you want to do, this data you want to send over the cloud or over the internet in the GitHub to store there, right, in their repository. So when you want to send this data, that time you have to write a command called git push command, what guys we have discussed in the last class, right? And with the git push command, you say in this master, even though in git push command you also write one more keyword called master, which branch you want to upload and where you want to upload. So in the GitHub, you have created on your own repository. Okay, this repository have their own URL, unique path. Okay, so while doing git push, you also say this is the repository, this repository information I given in my local system, let's say with the name called origin. So I would like to push my data to the git origin. So what is origin? This is one just a term I explained you again in my last class. So in your local system, you first have to update this your local system. Whenever I do push anything, I'm going to give the URL of my GitHub, and this URL information I store in one variable called origin, or you can give other variable name also. Okay, you will just update this information once, normally in your local system with the git remote command, and then in the future you can keep on using git push by this name to upload. But this command you guys know. So when I run this command, okay, what happened? Your local data will upload to GitHub. That's what we have discussed and seen also in the last class. But the interesting thing is, in this command, when you're using git push command, you mention your branch name or your timeline. So whatever branch name you mention, that particular branch will upload in the GitHub. You might have multiple branch, but only that particular branch will upload. And when I say branch means branch means your timeline. And what timeline contain? Commit 1, commit 2, and commit 3. But the important point here is to notice is, so when you upload into the GitHub, you commit 1 with V1, V2, and V3 in my case, all the commit will upload. But the interesting thing is you are mentioning master branch. Okay, it means the entire master branch upload, but technically, you know what they do behind the scene? They use this reference called head. So wherever you're pointing to, okay, current right now, wherever your pointer is, means whichever you guys are working on. Pointer means your head is one special variable, and head is pointing to commit 3 or version 3. So technically, we know in the master branch we are at commit 3. So whenever you push anything, okay, or you transfer your data from one branch to other branch, also same thing, because right now in the master branch, so when you upload also here, this is called push. Technically, this is also one kind of branch, you can say, the way you create a dev local branch or other feature branches, right? So in simple term, if you are doing any operations, almost any operations, right, in your commit area, that operation will always check where your head is. And wherever your head is, whichever the commit they are referencing to, they're connecting to you, they know till this commit. It is something like this. V3 is but let me write in this way. First we create V1, then V2, then V3. Okay, so my head is the one who know I'm here. Okay, so whatever you want to do, they will do in this area. But this area has this parent, this area has this parent. It means head is one variable they know about this entire data. So my you know what my point here is, there's a lot of scenario come up, okay, where my local developers, right? My local developers, not branch, normal developers who commit something on C3. This V3 actually commit created. But why after creating, they might not be very sure that this commit what I created, I save locally, is ready to go and upload in the GitHub. Because as you upload in the GitHub, I told you in my last class, normally we have a DevOps Jenkins is going on. And as soon as the commit in the GitHub, Jenkins will pick this data and deploy in the production system. So maybe they want to commit locally, but they also want, as soon as a commit locally, I don't want this data to be uploaded, sorry, in the GitHub. Okay, and whatever the commit, whatever normally we do in the commit area, any operations, there will be much more operations. I don't want to do anything right now in this area. Okay, my requirement is I want to provide my data till commit 2. Even the commit I did committed 3 or version 3, but I would like to only provide my commit to or data till my commit to in my commit area. So my point here is, guys, it's just a game of the head pointer. Okay, so when you upload something, you create a branch to put the commit area or timeline to a new branch. Your head can decide till what point you will provide your data for any operations in the future or for the commit area. So my point here is you can switch your head pointer to any of the commit area. Okay, you can shift either head here, you can shift either head here, you can take it forward, so backward, forward, reverse, rewind, all things you can do. And by shifting your head pointer here and there, lots of powerful capabilities you can generate. What are those? That was the lot of use case I'm going to discuss right now. But my point here is, wherever your head variable is pointing or having the reference of particular version or the commit area, on this data, all right? And till this data, your Git related commands mostly work. One of the simple example is Git push command. So when now if I do Git push, even though in my master branch we have 3 commits, but when I do Git push, my data will push till here. Okay, they skip this part. They have no visibility, I can say. Only they will push uh, till here. Okay, and much more kind of things, right? So when I do practical, I keep on showing you. But just wanted to give this information to you. Head pointer is very much critical, and lot of capabilities also they provide. What are those? I will discuss today. So what I'm going to do again, I go to git bash, just start to showing you these practicals and keep on adding multiple things as different use case. So this is git bash we have discussed in the last class, but today guys I want to, because there's lots of advanced practical is going to come up. So if you really want to understand what is going on behind the scene, this for example, this is one of the simple example I was talking about. So I'm going to show you one very powerful visual tool who help us to learn the concept very clearly, right? So if you go to GitHub of my account, okay, this is my account, all right, this called Linux World /13, and here there's one repository known as with known as one minute. There's one repository with which is what is the name I have given that point in time. Wait, is I forgot the name. So let me search in the other way. So there is a one powerful tool. Let me search Linux World 13. Okay, and over here, wait, is it is there in the Google. Okay, so let me quickly show you another way. So there's one powerful tool in the GitHub is called Git which I think I was writing the wrong spelling. Yeah, here it is. So this one. So this is one very powerful tool known as GitWiz. This is the URL we have. If I can somehow send this URL to you, I'm putting guys in the chat box for everyone. This is the URL in the chat box I put here in the Zoom meeting. So if you go to this particular URL, this is a very powerful tool to create a lot of visuals. All right, and here in this particular tool, you can download this software, and after download, you can install it and use it. How? So they give you one link. This is the one link they give you, release, where I get this software binary to download. Just click in this link. Click in this link, and there's option here to download the zip, right, of the latest version. So I'll click on the zip and download. That's all. Okay, after download is a clickable, just click and like it's called executable, just click and use it. Okay, so the zip file, click here, it will ask you to, do you want to extract? This is a archive. I say yes, I want to extract this guy. Where to extract, you can extract this particular software. Yeah, that's all. So in my case, I extracted in the download folder, and if I go to my download folder, so this is the folder they created, this is the folder they have, and there are multiple files we have, but this is the applications that I'm looking for. So GitWiz is a very interesting applications. It is a good way to learn the Git concept on the real time. So when you double click, this is the verify GitWiz command. That's all. Okay, how to use this? What is the power of this? Let me show you. So here they're asking you, can you tell me your local repo, means your local Git repo, right? So I can create some visuals for you. So what I'm going to do, I'll go to my Git bash. Okay, let me go to my documents folder. And in the last class, we have created Git, I think Git training folder. I think this folder we have created in the last class. No. So Git workforce, maybe workspace, whatever name we have given in last class. Maybe this one, doesn't matter, right? So this is one folder we have, we was working maybe on, and the last class. Now what I'm going to do, I'm going to create one more new work space, or this called local repository that I'm going to initialize, and let's say this will be my workspace level. Okay, so new workspace I am created. In this workspace, we have nothing to commit because this workspace is entirely empty. Okay, so what I'm going to do, I'm going to put one file, let's say a.txt. Okay, if now if I run the git status command, they say one file we added but is untracked. Okay, so I say let me add this file a.txt. Now this file is being tracked. It is there in the staging area. In the staging area, new file come up, but it is not still exist in my commit area. The only tracking that is there in the staging area. So you guys know how to commit. So I want to commit this file with a command called, let's say, commit number 1. So commit number 1 we have created here. Now this entire data stored, and now my local branch, master branch is clear. And then the git logs command, these are the guys commands we have discussed multiple times in the last classes. So this is the first commit with commit ID created with this message. Okay, so in my master branch, I have one commit that we can see with the log one line command also. But to see this thing very clearly with visuals, what I'm going to do, so my workspace WS1 is there in this folder, in my documents folder. So I'll go to my git viz, and there's option here to browse. So I go to my documents. In the document, I'll go to git workshop, right? And this particular WS11 I'm picking. And as soon as I click OK, what they do, this tool will pick this. And this try to show you in this kind of visuals that is very handy in one way. What I mean by this, let me one minute. Okay, so let me show you in this way, right? So technically what happened, as soon as I do something, they keep on highlighting, updating this visual tools that makes our life simple in the terms of learning and understanding, right? So when I say this, get log one line. Okay, so it is very clear. We have one command called 871, the same thing they're talking about 871. And because it's the last commit, and this commit is the part of my timeline. Okay, and where is my timeline? Timeline means the master branch. Okay, in the master branch, all the commit what you have, they show you. That's what they're talking about. So you have the master branch. Okay, the master branch. This data is a part of master branch, but because this is the last commit we have done, so head is pointing to this particular branch. It's not this particular branch. Head is also pointing to this commit ID. I explained to you already. We can change our head pointer here and there. What is use of this? We will discuss in some practical. So what I'm going to do, I'm going to create some more file. Let's say b.txt, and let me add this file. Okay, and now if I do commit again one more time, you'll see some live difference gonna come up. This is the commit number 2, and as you're committed, one more thing come on this branch, one more commit ID 84, and because 8435 is the last one, so my head is pointing to 8435 right now, even though we can see with the logs command also. So 8435, they are pointing uh, to right now. And let me do one more time very quickly. So I have big history, guys. This is normally also known as history. So history of my commit. So we have a big history over here. Okay, add in the staging area, and then I want to commit this thing. Let's say this commit number 3. Sorry, is a C. So commit 3 we have done, right? So this is history we have created. The main thing is head is pointing to this guy. And important point is wherever the head is pointing, okay. And now in this commit area, this is the commit history of my commit area. Any operation that you perform is performed based on the head, where the head is pointing. What I mean by this, let's say I want to create a branch, right? What is a branch? You guys know. I want to create a new timeline, okay, or new branch. So let's say get branch dev1. Okay, whether we can use this command also, get checkout, okay, B. So this will create a new branch dev1 plus also take you there. What branch it create? Okay, whatever the data you have, guys, in your master branch, we were creating the branch for the master. So whatever the data you have in the master branch in the commit area, we have 3 versions: v3, v2, v1. And because head is pointing to v3, okay, that is a reason whenever we create a new branch or new timeline, all right, this entire version v1, v2, v3 will come up here. It look like they come up here, but they're just creating a connections or the referencing, but everything come up here till v3. But why till v3? Because my head is pointing to v3. So when you create a new branch, let me show you very quickly. When a new branch created with this visual tool, okay, you choose the new branch, you are the dev1 branch, but what you are seeing, dev1 is also pointing to this one. And because right now you are into dev1 branch, so you now head is only one single pointer. They are now pointing to this branch. The head is a part of your dev1 branch. That head says that where you are working, which branch you are working, and this was in this branch, which pointer or which particular commit ID you are pointing to. Okay, so we can visualize in this way. So now my head pointer is here. Okay, in this branch, not here, and in this branch they're pointing to v3. By chance both the guys are same, so there's no meaning to have a copy. So internally they look like dev also have this commit history, but technically they are same. This one is the same, exactly what you have in the master. Okay, what you have the master, they are the same. The one thing. So this thing you guys know in the last class we discussed, right? But the main thing I would like to show you very first quick practical is just a game of the head branch. So what I mean by this, if I go back, let me check out to the master. Okay, so I would like to go to master now. Head, if you see guys here in the visual, head is now part of the master branch, and which the last commit is head is pointing to that particular commit. Okay, just quickly let me delete my branch because I want to create one more new branch. I don't want any confusion here. So let me delete the branch called dev1. I don't need right now. Now this branch deleted. Now we have only one single branch called master. Okay, and now what I'm doing here, I want to create again one more branch, but by default behavior is normally when we create the branch, entire data of this branch come to the new branch. But let's say we have some scenario, and scenario would be something like this. Even though guys, I want to show you one more quick thing before we go ahead as a quick revision, so we can compare also, right? So for the comparison, what I'm doing, I'm creating again one more branch that I showed you in the last class. Let's say dev1 again. Let's say this is my feature branch. Why I created? Because this guy have a requirement. They would like to add some more data, some more code, some more feature. Let's say d1.txt file. These guys created in this branch. They added in the staging area this file, and they committed from their particular branch. So as soon as you committed for number, let's say from dev1 branch. Okay, sorry. File number is called D1 committed. And now we can see your dev1 branch is one commit ahead. Your master is still pointing to EC2, the last third one. And now dev1 is pointing to 479. You can see from logs command also. So some of my developer take the copy from the master branch and start working on the next part or next feature. That's called feature. I explained this concept too in the last class. So this 47, this dev is one ahead of the commit of the master branch. And because right now we are working on the dev1 branch, so my head pointer, that is very important pointer, we keep on using this pointer multiple times, is pointing to this branch with this commit. Okay, let me do one more thing, one more time. Let's write d2.txt, creating a new file with the touch command. Same thing I'm doing here, add this file and commit this file with okay, so there my dev branch is two history or two commit ahead. And let's say this guy say my job is done. So what are things I change is we can merge into the master. What is merge? You guys know. So for this, I'll go and check out my master branch, or instead of checkout, what can you do? It is something like this: is before the dev1 branch you was in the master branch, so you can use switch command also. And there's an option called hyphen. So anybody who know about Linux command, in Linux we have cd command, and cd we have hyphen option. So cd command in the Linux means change directory. Hyphen means in the cd command in Linux means whichever directory you was previously, just history means previous folder, take me there. Okay, same thing, hyphen have the same meaning here in the Git. What they do, wherever you was in the last time before dev1 branch, you might be in the dev2 at dev3, but wherever you was, take me there. Okay, so because you was in the master branch, you take this guy will take you to the master branch. So you can quickly switching the thing back and previous by this option, rather than memorize the name, because sometimes name of the branch is very bigger sometime, and most of the cases I can say. So having this option will help you. Now if you see guys, head pointer is pointing to master branch of the latest commit, but dev1 is again two versions ahead. So I can say merge and with the dev1. So I'm in the master branch. What are two things they have done in the dev1 branch I want to merge in the master? Before I merge, you can see in the master branch only 3 files we have, but as you merge of dev1, that's what I saw in my last class also. Okay, what they do the merging, okay, very quickly, and this two file whatever you had it, now it is a part of my master branch also. See, same 0d47 id come on the top of this. Okay, and this kind of merging is called merging strategy, and here they're using the strategy called FF, this called fast forward strategy. Okay, but in this case you get, because in the master branch you stop there, you're not working forward in the master, your feature branch, dev1 branch is keep on adding multiple things and they merge back. Okay, so this kind of scenario I showed in my last class also, very simple scenario, but sometimes useful. But in this scenario, if you want to merge, then this is called fast forward merging. We have some more merging we'll discuss right now as we progress in this topic. Okay, and after we merge, we don't need anything in the dev1 branch, the feature branch job done. So mostly we normally delete this branch. So I don't need dev1 branch more, because the purpose of the dev1 branch is done. Okay, is done. So I can delete this guy also. The main branch is master. We can keep on working on the master as forward, right? So this is one thing. So guys, I'm just doing multiple things together, right? I'm showing you what is happening with these visuals, plus also revising some of the older concepts, so what we discussed in the last classes, plus keep on adding some new options also here. Plus, I'm also building the lab for my next practical. So multiple things I'm doing right now over here. Now, what I was talking about. So head is pointing to 0D42. As soon as I create a branch, okay, entire data of this branch will go to new branch. Okay, why entire data? Because head is pointing to 0D42. Okay, but what can you do? Okay, there's option called get checkout. Okay, even though if I run the get logs command also, one line. So my head is pointing to 0D42, but we can change my head pointer. Okay, right now we have this entire data come up in the master branch, but I want to say my get that there's a one per ID I want to go at this point in time. Okay, so what data I had at this point in time, because every command ID has the time also, the comments also. So we know what we had at this point in time. Maybe we have done multiple things here, but something is not working, is crashing. So our plan is, let me explain the plan, right? This makes more sense. So these are the things we have, and we reach here, but after we reach here, we found something very something back. We have done something that is causing the error, or maybe at this point in time we write a code. This code is been written in such a way that this code is connecting to some of my databases, and databases might not work fine. So I have to change the URL of the database of connectivity or something. So it will be anything. Or maybe at this point of time, we run a function, that function has some challenges, thing is not working. Maybe they are running till here, but there may some version change happen. Because the version change, some of the keyword of properties is not working the way we want. It will be anything. So I want to go here and fix this issue. So for this, right now your head is here. And normally, guys, normally to fixing the issue, we always get a feature branch. Is good practice, I can say. It good practice never directly work on the master branch to fixing some issues or adding some new feature. So we can do it, right? But it's not good practice. So head is pointing here. So, but what I want to create a new branch called dev1 to fix my issue. Or let's say I give the branch name called fix branch, all right, of my database, for example. And what I want in this branch, I don't want to have this entire data. I want what are data I had at this point in time. So this copy or this point in time data I want to put in this branch. But how it will work? We have to first create the branch. But when you create the branch, entire timeline come up. But I don't want this. So I have to first shift my head pointer here. Head pointer here. Okay. And after the head pointer come at this time or this point in time, then we can ask to create a new branch. And now when the new branch come up, this head pointer where the pointing to this data will go to this branch. And obviously this branch parent is this one, so their parent always goes. So this entire history or this part of the history or sub history, they will go there. Or maybe you can think in the Git, everything is arranged the way you guys see multiple times in the tree way. So this sub tree. Okay, so the entire sub tree will go to this particular branch. So whatever you want to understand, you can understand. Okay. So let me show you how it works. So let me first, for this, you have to change your pointer of the head. So that is, so for this, there's one of the way, the other way also for other different kind of use cases, but checkout is one of the way. I'm asking checkout to take my head pointer to 8435. Okay, even though before I do so, let me show you my history is clean, right? There is nothing to commit, everything is clean, right? And these are the 5 files we have here. Okay, and this is the history of our log. I will check out command and putting this, get commit, putting this number 8435, not commit, sorry, check out. So when I do so, you see this visual is very powerful. Very limited time we see this kind of options, right? The master is pointing to something else, head is pointing to something else. This is what you see. And this is a very special case or state, okay, where head is pointing in this timeline something previous, something back. Okay, this state is known as detached head state. So we detach the head from actual pointing where master is pointing to, and we take this head somewhere else. So now head is pointing to 8435. This is what I was explaining to you, right? The now head is pointing to this particular pointer. Okay, and because head is pointing to this particular pointer, so what happened? Now if the even multiple guys options they also give you, we'll discuss what commands they give to you. But now if I run the logs command, you can see now in the logs head is pointing to this guy. It doesn't mean your entire history removed, or whatever data you had at this point in time, that data will show you here. Okay, and at the same time, now if I do git check out, okay, and creating new branch, let's say I have some bug, so the bug fix branch I'm creating here, bug fix branch by dev1 developer. So this branch I am creating. So what happened? Because head is pointing to this one, so this bug fix dev1 branch again is pointing to this guy. Okay, and if I do ls, whatever data we had at this point in time, the data is only visible to this guy, the 2 file, or maybe this file 2 file has some kind of code. So that code and that kind of data, that point in time data will be visible to this particular developer. And now this developer started working on this, and let's say they create some more new file, or maybe they edit the file whatever we have. So let's say they create b1.txt file, right, to fixing this bug or adding the code also in the file. And after this, they will add this file in the staging area. They commit this file in that commit area, let's say b1 or has1, for example. So new, because obviously they change something, and after change they have to store in the commit area. So that's what they have done. Let me do one more time. Touch b2 bug, again they fixes new file they create, or they added something in the file, then they put in the staging area of the data or the file, and then they also again cut b2 commit, right? So this is done. So guys, you can see this look like a tree. Okay, so from here we start, then we have a two, okay, this is called diversion in the tree. Now we have two diversion. Okay, master branch has a different timeline, bug fix branch has a different timeline. Some is we have a common thing in between. Okay, common thing in between, and something like this. Okay, but now after they do bug fixes, now it's time to again, because one branch or bug fix branch has added two things, added two features. They might test it, thing is working fine. So whatever change they have done, I want to merge back to the master. Okay, so how can we do? So for this, we have to first go to the master, check out master command. So checkout guys has a two possibility. Checkout will take you to the different branch also, plus they take you at that point in time also of the commit ID. So now in the master, if you see the log one line, in the master we have again this 5 commits. That's what we had. Well, last time they were showing only 2 because we changed the head, but when we again shift to the master, the head is automatic reset to the top where the master is pointing to. Okay, now in this example, what I want to tell you, okay, what of the bug is fixes, but their one branch is not come up here because they create two files. Those two files doesn't come up here because we haven't merged it. We haven't merged it, right? So what we have to do technically, it is very interesting concept in merging. The last merge that I showed to you, okay, that tree is a little bit different, right? So the last merge that I showed to you, we have a first version, then second version v1, v2, then v3, my master is pointing till here. Then we create a new branch, dev1 branch, for example. Then this guy is created v4 on the top of this. Then they created v5 on the top of this. So this data we create in dev1, and this data still we have in the master. Now what we had done, we have to just add this data on the top of this. Let's go merge. Okay, so adding any data, there's already there a continuity on the top of this, not big issue. So the merging that we have seen multiple times till now, okay, is something what they're doing. They're just adding the data on the top of master. So what the data we added in the dev1, same data they're adding exactly the pick and put on the top of the master. Okay, and adding is so simple. Why? Because master know where you're pointing to. Okay, master know the last commit. Okay, and whatever they have the extra differential, they will add on the top of this. That is the reason this is called fast forward merge. But here the scenario is very different. If you compare, here the scenario is a little bit different. The scenario would be, okay, whatever the commit we have done is not on the top of my last commit of the master. Okay, this changes whatever we have done. This is the first change we have done. This is the next change we have done in my dev1 or bug fix branch. Okay, those changes are on the top of this guy. Okay, not on the top of my last commit on where the master and head is pointing technically. Okay, this change we have done in some of my other commit area. Let's say, let me give this commit boxes a name node. So let's say there's a node. So there's a node 1, node 2, okay, node 3, node 4, node 5, or maybe we can give the version 1, version 2, version 3, and let's say this is 10 or this is 11. Okay, so if you are at the fifth node, and on the top of this, if you create a new branch and add 6, 7 there, then adding on the top of this, it would be like this kind of scenario that we have seen today and last class also. Merging would be then not big deal. We can very simply logically that merge will done this called fast forward. But here merging is not so simple. Why? We have to first go back. Does my branch that I create a feature branch, they will start from here? No. We'll go back. Does they start from here? No. We'll go back. They start from here? No. We'll go back. We start from here? Yes. First, we have to go back in my history, keep on checking, and then we have to check the difference here, what difference they have added, what are the name commit they given to you. They pick these details and then they have to add on the top of this. Okay, so as a programming, those who know any programming or a concept of DSA, data structure algorithms, if you know, then this is mostly look like a recursion concept. We check here, no, we go back, we go back, and then we again come up and add this guy on the top of this, right? So again, we are not in DSA classes, but it more look like recursion. Okay, so what I mean by this, let me show you with practical. So technically, this is the information we have in the master branch. Right now, we're in the master branch, right? So what I'm going to do, I'm going to merge, okay, my bug fix branch, okay, in the master. And if you notice, guys, in the master, last commit is 0D. Okay, and my bug fix last commit is DA and 5D. So when I do this merging, okay, this time, guys, while merging, they open my by default text editor. In your case, maybe they open VI and maybe something like this, and they're asking you're merging. So can you pass some merge message here? Why you're merging? So for the future reference. So in this merging, they have to use some specialized concept. Let me also explain what they're going to do in this kind of merging, what they are going to do behind the scene. Okay, in this merging, they pick this data, okay, on the top of master and create a new commit. Okay, let me show you. And because they're creating a new commit, that is the reason they are asking to give some commit message. Okay, so let's say my commit message is merging bug fix into master. Okay, and bug fix of 2 days back or 3 days ago, something. So some message on bug fixes we have long back. Somebody had done this, other developer had done this. I go to the rate time and I fix the bug of that particular point in time. Okay, and I close. So this is one commit message we have put. All right, and I save. Okay. So now guys, you will see some difference here. Very interesting tree they created. Okay. And now what you are seeing, whatever data you have in D, A, and 5B in the bug fix branch, they take these two, uh, DA and 5B of my bug fix branch commit. They take this both commits. In this commit, we have created two files or maybe some more data in this, or change some other data also, other files. We take everything and send this entire data and merge the entire data in my master branch, okay, with a new commit. This is called A2. So last time, guys, I had OD. If I show you here, last time I had OD, last one, but this entire data they store in a new commit in the master. Okay, new commit in the master, and this is a good strategy actually. Maybe this data, if they add on the top of the master, might not work the way we wanted. So that is one of the reason they take this entire data and put in the different commit area, also in commit ID. Why they put in the different commit ID? Maybe this might not work, so we can remove this commit ID, last commit history ID, and again it's still working till here. So maybe other benefit also you get. Okay, you will achieve here. But this is what they create behind the scene. Okay, behind the scene. And now if you do ls, here, you will see the entire data come in the master branch. These two things we have changed there, come here. But this kind of strategy, guys, is known as, because Intel they work with the concept of recursion. So this strategy of merging is known as recursion strategy or recursive strategy. It's called recursive merging strategy. Okay, but recursive merging strategy is a little bit older. They have some small bugs. Okay, to fix the bug, all right, they after fixing the bug, they give this recursive strategy a different name. It is recursive only, but they have some small things they changes. One thing they changes is previously what we used to do, we take this data and add on the top of this. Okay, something like this we was doing previously, right? But instead nowadays what they do, right now, guys, we are using Git version 2 with some 2 point some version, right? So in the updated version of the Git, what they have done now in the recursive, they take this data rather than they copy this entire data. Okay, they will take this data and put this entire data in the new version and new commit. Okay, and new commit ID they created, new version they created. That will give a lot of benefit in the terms of management. Okay, so that is the reason, guys, nowadays in the latest version of Git, mostly we don't use recursive. Instead of recursive, we have some advanced version of recursive that is called ORT strategy. So whenever you see ORT strategy, it is like the concept I explained to you. It is more like a recursive or this advanced version of recursive, that where they add some extra benefit and features on the top of recursive, right? So, so technically you don't have to worry about Git will take care of all those concepts to you, right? But they're trying to tell you what strategy they are using behind the scene. So this is the example of ORT, or I can say the recursive strategy, what they're doing here. Okay. So this is a one thing to note here. And after this, you think your bug fix, your branch work done. So you can use get branch to delete this particular branch. Now branch is deleted. Now your history is clear. That branch has been deleted. Okay, but still we have this data, maybe because this is pointing to this one, so that's what they come up here. So we have this branch diversion, right? So we'll fix this if you want. but this is what they have created. Okay, so this is one. I'm just trying to show you multiple different use case. I don't know which use case gonna help you, but almost every use case, guys, depend upon the area to area or requirement to requirement help you. Okay, so branching is very common thing, merging is very common thing, depend upon the use case and the requirement. We have to use that particular things. There's one, right? Now, this one small topic done. We keep on adding multiple topic as we progress. Much more concepts you're gonna see in the upcoming discussion over here. So this is one concept of merging, and with some extra strategy we have done. Plus, the important point here is I would like to explain you this graphical tool, and I would also want to explain the meaning of the head, or I would like to also explain you the meaning of checkout also. So these are the things, guys, I want to tell you. That's what I cover here. Okay, now do one thing. I have some more interesting things to do on the command line. Let me show you very quickly. Okay, for this, let me come out. Let's create a new repository locally, so it will be clean, so we can focus cleanly in this area. So this is a new repository created. Okay, nothing is here. And to make a proper visuals, let me change the name here, the different name. So this is 12. So in the 12 repository, I have no data. Okay. And now what I'm going to do here, and master plan, let me show you in a minute. So my plan is something like this. Let me first add some data. Touch a.txt. Guys, there's a concept called merge conflicts also. We'll discuss in some time, right? I just want first to comfortable with some of the key part of the git add, and guys, you say as soon as create a commit, okay, a.txt, I create a commit, let's say with first commit. Okay, as soon as I create a commit, automatically guys, this graph created. It means till the time you don't create a commit, there's no timeline created technically. They might show you master name here, but there's no SS timeline created. But as soon as you do first commit, timeline created, commit ID created, and they start pointing to the head. Okay, this is what I want to tell you. Now, what I'm going to do here. Let me add one more b.txt, one more file. Let me add this file b.txt. Okay, and again commit. Okay, F2 b.txt. So again, I'm creating the same history here very quickly. One more history created, and do one more time very quickly. And now my motto here is something like this. I do some changes in my file, and I commit something. Okay, but while committing, I write a commit, because guys, comment, when you do commit, we always write the comment, and comment has a very much importance we have in the comments, because IDs is very harder to understand, right? Commit, when normally, let me just give a commit name. Let's say bad commit info we have given, not understandable. Just I'm intentionally write this name here. So what I mean by this, what I want to tell you here. Oh, 1 minute. c.txt. Let me first add c.txt, and after add, let me commit. And now what I'm trying to tell you here is, okay, normally guys, we use of versions to control, we go back, but if you want to go back this point in time, I don't know what I had at this point in time. My comments is the one who gonna help me. At this point in time, what you do, some changes, you add something, you add some content in this file for this purpose. So having the better comments is very, very important. But sometime, okay, somebody might have written a bad comments and comment doesn't make any sense. Okay, and this comment is stored in your history, okay, and with this particular commit ID. So my point here is, if you want to go in your history and want to change something in the history, again, I'm repeating, guys, you can go in the history and want to change something on the history. Okay, here I'm not asking you to add a new branch and merge back something like this. My plan is very straightforward. I want to go in my history, okay, and I want to change something in the history that I write somewhere wrong or something like this. For example, just simple example is I want to change my comment here, what I put in my history. Okay, so how can you do this? So for this, we have a concept called amend. So if you want to go in the history, I want to change something in the history. So there's one concept called amend we can use. This is what the concept we use in normal books also. So in the books, somebody published this and and we want to add something or change something in the rule and policies. We amendment is going on or something we amend, like something like this. So I want to go back and change in my history of something very useful. How can we do? So for this, guys, can you hold for a second, please? So for this, what normally we do, let's say I don't want this commit to be used. So idea is very simple. Whatever you think you want to change, maybe you want to change your commit comments, or maybe you want to change some data or the code. Always good practice, not compulsory, always good practice to create a branch. Okay. So this is the history we have. I'm going to create a new branch. Okay. And let's say this branch for amend branch, or I want to do amendment. So let's say this amendment branch I created here. Okay. So it's B to create a new branch. Okay. And now if you see the logs again in this branch also, same kind of comment or commit message come up. My plan here to change my comment message. So after going to this branch, then I do some changes. Why go to branch? If some mistake can happen, we can remove this branch. It doesn't impact the master branch. That is again one of the reason to create a branch, separate branch to do some changes. Now, now to doing some changes, okay, I can again say I want to again commit. I have no change to commit, but I want to commit, all right, with a new message. Let's say new message, or I can say correct message, all right, what I want to put in my history. Okay, but I wanted whatever the message I have in 131 FD comment message, I want to change this with this message. If we're going to change, then there's an option we have to write here is called amend. This guys, the amend you have to do. But what amend do behind the scenes, very important to know. Okay, it's very interesting also. So what amend do? Amend do whatever data we have here. Whatever data we have here. Amend will create one more new commit area. Let's say with a name called A, B, C, D, something like this. And this data, entire data entirely copied here. Okay, you can think in this way. And after committing or new commit ID, this commit ID, they give a new commit comments. This comment they give to this ID. Okay. And then everybody start pointing to this data. So in this case, what happened whenever you do any amend, this is what they do. In this amend, so finally it will look like this. So everybody is start pointing to this ABCD. What ABC content, the exact same data what I have in this particular node or in this particular commit area, or not commit, commit object. Okay, and this guy again still pointing this one, and they still pointing this one. So technically what happened, right? They remove this node from this tree. So let's say this is the entire tree. okay, or maybe my branch, master branch or the amend branch. So in this tree or in this particular hierarchy, they take a new node, okay, with the latest data or the commits, okay, and remaining would be same. But this one where we have done some small mistakes and error, this will be removed from this branch. Okay, but interesting thing is they remove from the branch, but they will still exist in your repository. What I mean by this. So if I show you here, when I run this commit, okay, very interesting things gonna come up here. So 131 is connected here, and you can see there's a come little bit in dark green kind of color. But as soon as you amend, okay, so what you will see, they have done amendment at this point in time, one file change, something happened. And if you see your history again, now you have a latest updated data, okay, latest updated data that you see over here. Okay, last data was this one, but now they come with new updated data. And how they done? They added one new commit on the top of this, and they still pointing, and they start pointing to append branch. This is what guys they do behind the scene. Okay, and that's what. Now if you can do merging, you can do the merge. Maybe in this merging you might have faced some kind of conflicts, so I will talk about the conflict, and when the conflict come up, we have to remove this part and do some more changes. I will talk about this. So conflicts we haven't discussed, but this is a way you can do these things. Or maybe you want to do one more time. Let me do one more time with a new message. Let's say 1 2 3 4. I'm doing one more commit, and still I'm in the event branch. Okay, and whenever you do some changes, guys, all the changes always happen in the head where you're pointing the head. But you want to do some change here, you do just first change your head to this point. How to change, I told you. So mostly any of the command I told you, they will perform on the commit object where head is pointed. Okay, so I'm doing one more time these changes. Okay, and at this time, guys, I just what I want to tell you, right? This time, because amend will always create a new commit. Last time it is BD56. Okay, now this time they remove BD56. Sorry, I ran one multiple times. So they remove last one and create a new one, 60F. Okay. Now, interesting thing that I was wanted to tell you, in the same branch, if you have your head initially, guys, in this branch, your head is pointing to this guy. We amended, they created a new object. Okay. Then we amended, they created a new object. So whenever you do amend always create a new object or new node. And whatever data you had here, they copy here. Whatever data you had here, they copied here. Okay. Amend means mainly, let's say I want to change my commit. There where we are using amend here. Okay. But interesting thing here is in amend, they create a new object, and that object they create and put in their main tree and main timeline. Okay. And whatever they put in the main timeline, this node is the part of this tree, and whatever data in this node, it is being usable and accessible. This concept, guys, is known as reachable. So my this node or my this particular commit area or commit object is reachable. But if you see here, these two guys, because we already amended, entire data is already copied, commit message has been updated, so there is no use of it. So this two guys is not connected to any of the timeline. See here, guys, neither master branch connected or neither amend branch connected. It means if I show you very quickly, in the amend branch, this branch, they only show you 61 to B8, 61 to B8. Okay, only these three guys are showing. These two are not part of the amend branch. Even though if you just check out master also, if you see the timeline on the master, they show you 1 3 1 2F and B8, 1 3 1 1 2F and B8. Okay, so lot of operation that you will see, and also multiple other operation also you will see. Okay, there is a possibility. Okay, when you do some amend or some other kind of operations also, that particular object or commit object will no longer the part of any of the branch. In that kind of scenario, that object or that particular commit ID, okay, is known as orphan, right? Because now this guy has no parent. Everyone has their own parent, okay, but this guy has their no parent. So in this case, this guy is known as orphan node. Or we can say one more term we can use here. These guys are is like an unreachable. So there's this guy is not there in the history, right? So how can we reach? We have some way, but technically we can't reach the normal way we reach to these guys. So these are known as unreachable node or unreachable commit areas. Okay, but typically it is known as orphan nodes or orphan commit IDs. Okay, this is one thing. So technically, if I again, if I shift back to my amend branch, this branch, we can see these guys from here. So log command as such have no capability to show you the orphan or the unreachable nodes. Logs command only show you the versions or the commits they are reachable, who is connected in this tree. 60 connected 1 to 1, 1 to 1 connected B8. Logs command only show you the one that is connected in this particular tree or in this branch or the timeline. But if you have a requirement, you want to see all the history, either they are reachable or unreachable in any of the scenarios. Okay, because there will be a lot more scenario going to come up where you will see orphan node created. They are unreachable. By default, this git wish tool is showing you this unreachable thing, but command line logs is not showing you. But if you want to see the entire history, either they're reachable or not reachable, then we have a fantastic command. Instead of logs command, okay, we can use a command called reflog. So reflog is a very powerful command. They give a lot more details also. So what reflog will tell you? Everything. Okay, even though whatever the operation we do have done, they also show you. So whenever you do checkout also, they also maintain this. So they will tell you at this point in time, you check out from this branch to this branch. Again, you move from this branch to this branch. So reflog is maintaining almost entire history what you have done in the Git. Okay, so they're very clear. They say you have committed F1, then F2, then you committed with this message at this point in time. Then you move to this branch at the same point. Then you change something here, BD56, BD56, they're showing you here. Then you change 7 to 9. Okay, then you change 6TF. So everything else they show you. So reflog is a great command, even though all the operations that you normally do. Okay, then you again check for master to amend. Okay, so everything they created in a history for the future reference. Okay, so it's called reference log. So anything you want to check, even though some branch is some ID become orphan or unreachable, it is visible here. Okay, and one of the benefit is maybe we do some operations like amend we have done 60 FE created. Okay, but maybe I have a requirement. This is unreachable. There's no way, right? In none of the branches it is visible, this data. But I want to go to this ID to do something or want to check something. Maybe some part when I do amending might not working, or maybe I want to take this data to do some more things, right? So my plan is something like this. Even though they are unreachable, okay, but let's say I have a requirement to just go and check what I had here. Okay, so or maybe I want to take some copy of this data, or maybe my requirement, because this is unreachable, so my plan is to remove this guy from this tree because there's no use of it. But before I remove, I want to check what data we have, so that before the remove we can do some kind of backup and copy, something like this. So it would be anything. Would be anything. So for this, again, we can use one powerful command that I already show you is called checkout. So we can say git checkout. Okay, and I want my head pointer will go to 729 FDA0. Okay, so even though this is unreachable, but if you know the ID either by this tool or maybe reflog, so reflog gave me this ID, for example, I will switch myself to this one. So my head is now connected, and because as soon as head connected, now this guy is visible because somebody has the parent on the top of this. Okay, now they're connected again. And then I want to check something is there or not. So better way is to again create a branch, new branch. Let's say check branch I created here. Now in this branch, the entire data come up 729. So if we see the logs command, now 729 again come up as a reachable, then 121 and this one. So we can see what data we had at this point in time. If you think is good, it's not important. We can see the difference. How to see the difference, you guys know. Difference between this one and this one. See the data, what data we added with a cat command, cat list or cat file command. I'll show you. Okay, just use this show command you can use to see what changes we have done here at this point in time. If you think nothing very special, so it means we don't need this node technically, just what I want to investigate here. Okay, so what can you do? Again, you go back to your branch called amend again. Okay, after go to this branch, I don't need this check B branch because I just created this branch for checking and testing this particular unreachable node. So let me delete this branch. Okay, one more thing, guys. Now, when you delete the branch, okay, they're saying this branch is connected to 729, but 729 is not the part of master branch and amend branch. This node 729 is not a part of any of the branch. Is not yet merged. So if you delete this branch, you will lose this data. So are you sure? I say yes, I'm sure, because I will check this 729 FD doesn't contain anything. So I'm pretty sure I want to delete forcefully, and for this you have to use D capital. They also guide you. You can use D capital to delete this. So this branch again deleted. Okay, and as soon the branch deleted, so this node again still exists here, but now in unreachable because nobody is connected to this node, and this is not a part of any of the branch. So again, this 729 is unreachable. It's like an orphan node. Okay. So why are these all these operations? My plan here is to clean this tree. Unwanted pieces I want to remove, because amend is one of the operations like this. There's hundreds of different operations, not 100 different operations, 100 different use case will create this kind of orphan node, unreachable node. Okay, so your tree becomes very complex in terms of look and feel. So it's good practice to keep on cleaning the tree time to time. It's good practice to do, but before clean, it's also again a good practice sometime to first check before cleaning this thing. So my plan is something like this. Okay, what I want to do in this entire data. Okay, these node that is there little bit darker green color are having some data and they're connected to the timeline. So these guys connected to this timeline, and these guys are connected to this timeline, but none of the timeline or branch is connected this node and this node. Okay, why? Because amend operation we have done, or maybe some other operation we might also have done. Maybe some extra branch we created. This branch do multiple commits, where we directly delete the branch and we haven't merged that branch. So that is also one of the reason you mostly see the unreachable nodes and the orphan nodes. Okay, so so when you do logs command or reflog command, they will all come in the history, make the history very bigger. There is no requirement of this. So what can we do? What can we do? We can ask my reflog first, just go and search all the node that expired. Okay, so it's something like this. I can tell my reflog. So, but let me tell you guys, let me tell you my intention here. My intention here is all the node unreachable, typically called expire. I want to clean this. Typically, guys, in the programming world, something kind of scenario also come up in programming world. And in this scenario, when we create some variable, we put the data on the RAM, or maybe in the future, that variable we don't want to use. Okay, but my data is still exists on the RAM. So time to time we have to clean it, and for this, mostly in most of the programming world, either we can use by ourselves or they might have a internal capability called GC, garbage collector. Same thing we are going to do here. So will call the garbage collector and say whatever data that are expired, I want you clean it. Just remove it. And removing is guys called prune. Just prune that data. Okay, so we'll call garbage collector to remove unwanted garbage from here. Sorry. So for this, first we'll ask my ref log. Is the entire history you have. But in this entire history, what I wanted to know. Okay, can you show me something about expire? So they have an option called expire. Okay, and in the expire, those things that is unreachable. There's one option called expire unreachable. Reachable. Okay, now. So till now, all the things that are unreachable, can you store somewhere in the variable? And everything, there's option called all, everything. So there's one option, guys. Technically, what this option do in the ref log, this option will go in the ref log history. Okay, and what they do, they will see all the data that is unreachable and store some in something in the internal variable, right? So it's not visible here, but ref log internally store everything in some kind of internal variable, and after they store in the internal variable, then we can call garbage collector. Okay, so again I'm repeating, guys, ref log, when we run this command, okay, ref log will expire from the history. Okay, everything that is unreachable. So all the node, even though if you see here, last time ref log showed me 7 2 also, right? 7 2 9. Now they are not showing a 7 2 9. BD, they're not showing you BD. So what we are saying here, till now, anything that is unreachable, expired. Which one? All. All the node expired. So in the ref log, the 7 to 9 B to 5 is being removed. Or I can say ref log behind the scene tag something somewhere and say, don't show me these guys. Okay, this is what ref log do here right now. Now, after this, we can call a garbage collector. This command called GC and say whatever data ref log has, clean right now, there's no unreachable, just prune this data now, till now. Because obviously, guys, in the real time, you can say those will be cleaned. Okay, so typically, these are 2 lines operation we always do normally, very common operations. Right? So whenever you can see this kind of operations, means any node come unreachable, run this command and run this command, and thing will be clean. So time to time, guys, we have to keep on doing these operations because very lot of going to come up where thing will be unreachable. Then you have to perform this operation. That's the whole idea. So this is one thing. Otherwise, there's some more operation we can do on the ref log. Okay, so ref log, guys, this is now clean history. Unwanted and reachable thing is been removed. Okay, and in my last class, I had told you the head is the one thing that is pointing to, but this is called head 0. Whatever previous comment is called head 1, head 2, head 3, something like this. Even though they give the name also head 1, head 2, head 3. Okay, so what can we say here? Ref log do one thing in my head, all right, and this symbol called @ here and curly braces, let's say 0. Okay, so what this means, whatever data you have till 0 show. So till 0 they have 1 2 3 4 6 5 till 5, they show you entire data. I can say reflog, can you show me data till 3? So whatever data you have till 3, 4 and 5, they show you. So technically in the tree, okay, you don't want to print the entire tree, means entire data. Okay, you just want to print the data till 3, means this goes subtree. Okay, so technically for another ref log again. So this is the entire information or the tree of the information, right? I want to see data till here. Just maybe I want to analyze something. So this is the good operations we can perform. Even though one more interesting thing is ref log has one more powerful concept. Maybe sometime we don't actually remember 3 and 4 and 5. I don't know what 4 means, right? It's very harder to memorize what we have done at this point in time, but at least we memorize one small thing, that 2 day back we'd have done something, or 10 day back we have done something. So what we can do here, we can write 2 days ago. So this is one kind of keyword you can write. So show me all the history, all the references, what we have done 2 day back. So we haven't done anything 2 day back because this is what we have created right now. But this also option we can write in the terms of filtering to take you back 2 days. Okay, so instead of days, we can write minutes also, like say 2 minutes, hours, weeks. So these keywords we can write minutes. So show me what you have 2 minutes back. So this is the data we have 2 minutes back as such. And then now the data we have changed 2 minutes back. Okay, so just go and check what they support, minutes or minutes. I think minutes. So sorry, actually it's not minutes, it's minutes. That's what they're not talking about. So show me data till 2 minutes ago. So all the history that I created 2 minutes ago, show it. So we can go for years, months, and do the things. Okay, so this is guys sometimes because lots of changes we keep on doing. Okay, we can go and see 2 minutes back. There's so much history. We have the comments here. By looking at the comment, we think maybe this is the things might not working the way I wanted, or done by some developer. We could go to this ID, check out, put in the branch, just go and look at this point in time, do some changes, merge, maybe some no, maybe orphan, amend, clean. So all the operation guys work in this way. Okay, so filtering, find out the right commit, ID, check out, and do the further things, right? So these are the guys some interesting options you guys can use to perform. Okay, so this one set of information I have given to you, right? Now one more quick information I want to tell you here. Before this, any queries guys if you have, you can discuss. Otherwise I will go to GitHub again and I show you some more concept of connectivity of a local branch to GitHub that I'll show you in my last class, but there's some more interesting option I want to proceed with the GitHub. Okay, but a lot of information guys I'm trying to show you. Every information has some and better use cases. I try to show you and explain you those use cases also, and accordingly we are testing these capability and the features. I'll share one document to you where you find these kind of commands, plus I'll share this history also in your respective Google Drive. So till now, any queries if you have, you guys can ask me. Okay, then we go for a small break. After break, we'll continue with the next topic. Okay. So what is definitely git reset and checkout? That's what the next topic Arga will talk about. Okay, checkout, I think you understood. Okay, git reset also do something like this, but there's some extra differences they have there. What reset will do after the break, I will talk about. So git reset hard will do something else, soft will do something else. Look like checkout, but they have a different capability I will talk about. Okay, so if I do merge at this point in Satya, unreachable branch never merge. Unreachable branch is not connected, so they want to merge when you do merging here. right? But if you want to merge it, then you to first connect the unreachable branch with some new branch. I show you already. First connect this with checkout, create a new branch, and then you can merge. There's a different point. But yeah, unreachable node doesn't merge in the new branch or any other branch. Okay. So so technically, guys, this one small confusion always happen, right? This reflog command is not removing anything from the commit area, I can say. This line is only removing the information from the ref log history. Okay, that this 2 or 3 node is expire and reachable, but they're not removed from the commit history or the commit area. So for this, you have to use GC garbage collector to remove that part. Okay. But how garbage collector know which part to remove? So they internally use this command reference. So when we run this command, internally this command will create some kind of temporary variable there where they maintain this 2 node we find out is unreachable. I'm removing from my history. Okay. But if you want, you can also remove from the commit area also. Okay. So this is a different command. This is a different command. Reflog. This only removing from the reflog history, but your node still exists in the commit area. Garbage collector then go to this commit area and check internal reference, means whatever these guys said remove from the history, they take these guys and prune from it, means remove from it. So typically these 2 guys commands always go together. Wherever you see first we first run this, then we run this normal sequence. Okay, because GC will take the reference from this command only. While pruning means remove from the history. You can see from here also they remove from the history from the visuals. so that's the one thing. Git checkout means different with git checkout and switch. Okay. Checkout, if I say, is a very simple way. Switch is the way you can switch between the branches. This is the typical use of the switch between the branches. But the main use of git checkout is with the help of checkout, you can go to any point in time. Okay, or main use of checkout is you take your head and you can go to any particular node the way I showed to you. So right now my head is to 60 FE, but I want to go to B86. So I can use my checkout command to go at this point or take my head to this point, same thing. But switch is a way to switch between the branch. Even though you can use switch command also to change the branch also. What you say is the best way to practice and memorize this concept? Actually, don't try to memorize Bandhu, Gati, whatever name you have. Don't try to memorize the commands, I can say. Okay, also not the concepts, right? Either whenever you get a chance of working on the real world, or either you're working in some company already in big projects. Okay, so just look on the scenario, what scenario of what use case you're facing there, and try to relate the scenario what I'm explaining to you right now, and then try to run those commands. Or the other way would be the way I'm showing you right now is a practical, right? I created our own lab. I add multiple things. I create new branch, then try to merge, then add checkout, change my head here and there, then merge. So what I'm talking about here is try to create your own repo here, multiple commits you do and multiple changes you try, and you will see when you do so, automatically new challenge you'll face, new problem you will face over here. And there might be possibilities, there might be some scenario you might create that might not be discussed in training, or there might not be access available somewhere in the blog. That would be a good challenge for you to just try to solve it. But my point here is, I think I'm clear. Don't memorize, okay? And for practice, build your thing the way I started from first day, and use that respective command, then add some more thing, use the plus as one more command. But the best way I can guide you here is just try to understand, if you work in the real world in some projects, what normally you do. You add a code, you save, then you add a code, you save, then you add a code, you save, then you come back, change something, then you save. Okay, just keep this example in mind, and then try to think what is the best practices you're going to use at that point in time, because everyone has their own meaning of best practices, depend to company, environment to environment, and use case to use case. But for that point in time, just think as a management perspective, what best practice you can use over there to entire management. Means if you want to do some changes, you want to go back, either you will do something directly on the master branch that this will use, or if you do directly on the master branch, if something happened wrong, then master branch is the main branch, we don't have access other copy, or master branch is one where every my Jenkins or other production kind of pipeline connected. Okay, so it means logically it's always good practice to work separately as a backup copy, or separate copies for separate branch, work there, test there, everything work fine, we switch back. If not working fine, we can remove the entire branch. Okay, and then if branch is working great, then we have to merge back, and merge back depend upon where we are merging, different strategies gonna come up, right? So slowly if I start building, don't actually jump to this entire command. We are under training. My motto is to explain you all the use cases, all the commands, but we don't have to actually jump to all the commands. Slowly start building the things. So no, Herschel, amend command is not only to change the comments, right? There's also one good use case of the amend command is in the last history, if you added any new file, okay, and if you want to amend the file, you want to remove the file, add a new file, okay, there also you can use the amend. Okay, means in that particular node or the commit object, if you want to do any amend, either comments or any data inside that comment, you can amend. So you can use amend for that purpose also. Okay. Yes, prune we definitely require Rahul. I show you this. This is the one of the reason, guys, why I opened this box. If you run this reflog command, they only remove from the reflog history, but my data still exists in the commit area. How can I see? So from this visual, I show you guys that both the guys exist till the time we run the GC garbage collector. Garbage collector is the one who will remove from the commit area. So right now, guys, I'm not discussing anything about bit bucket, okay, and because right now my focus more on Git and GitHub. If we get the time tomorrow, we will definitely talk about the difference with other tooling, all right, because we are in Git and GitHub. So my plan focus to be more on this tool. Okay, so right now some of the guys asking about the bit bucket and the comparisons. So I'm not doing right now. Git Kraken, Arvind, is a very great tool. Maybe tomorrow I'm going to introduce you Git Kraken. Git Viz is just a visual tool, just a showing with the visuals. But Git Kraken is a complete desktop tool. A lot of visuals they show you everything we can do graphically. It's like a GUI kind of tool. So tomorrow I have planned to introduce you Git Kraken. Very interesting tool. You definitely love it, right? Those who doesn't know about Git Kraken. Okay, so yes, Nikhil, amend branch or amend. When you do any amend, they always create an orphan node. Okay, because technically amend means they create, because we are doing something, you are adding something or changing something. And when you change something, you do commit. Okay, that is a reason amend is a part of commit, right? So if you want to do amend, you have to use commit command. Git commit, then amend. Okay, amending something means editing, at least doing some changes, adding something or removing something, or maybe updating the comments. So amend always create a new commit, and when new commit create, so there's no meaning of the old commits because we are amending. Amending means you're changing. So why we need the older one? Okay. So amend always create an orphan node, and any orphan node we have normally we do clean. So normally after amend, well, operation something like this, we it's good practice to clean it. Okay. Normally, maybe you guys might not have done cleaning till date if you're working on it, because typically we don't focus on this kind of graphical tool visuals. They are the one who show you all the nodes are disconnect unreachable, or maybe sometimes we don't focus more on ref log. Okay, like something like this ref log, and see there's multiple commits we have, which is reachable, which is not reachable. So it's harder to see here, right? So, so technically after amend, after multiple amends, maybe is keep on good practice to keep on doing cleaning. Otherwise, you unwanted wasting your commit area. And the main thing is not about wasting the commit area. It is about having the big history in ref log, and bigger the history you have unwanted, it takes a lot of time to understand this data also. So better clean history you have, you can analyze more perfectly, I can say, in the better way. So how reflow identify unreachable? Pretty simple. Technically, if you try to understand, they are anybody who have no parent are unreachable. That's all. So as a programmatically they understood, do you have any parent? Okay, because if you have a parent, you should be connected with, you should have to give the reference back. So every node is a one kind of commit object, and every object, right, has one property internally as a programming property where they maintain the address of the parent. So any node that is not maintaining the address of the parent, it but obvious they are orphan or have no connectivity any of the branch. So that's what guys reflog use behind the scene to find out which one is unreachable. Yes, Sumit, cloud computing exists. Cloud computer also exists. Billions of dollars investing by all the top company and the governments in the world, and the applications also exist. Okay, it is not the theoretical at this point. At this point where I'm talking right now, on 5th of March 2022, there's a lot of applications is been run on the top of quantum computing. One of the good example is in the US military, especially in Air Force, they're using quantum computing, real counter computers by a company called D-Wave, I believe they're using to solve some of their powerful use cases that none of the supercomputer can solve. Okay. So guys, maybe guys, those who are maybe a little bit new in the GitHub, some of the topic might look a little bit complex sometime, or maybe a little bit advanced, maybe, but it's good to know all those concepts, because what I feel a lot of time we take Git as a an underestimate tool, right? We think there's some basic option to use, but not like this. There's ton more options and different use cases for big project management. Knowing these concepts is very critical. Otherwise, management of big projects, right, and the code management would be very hard, impossible, maybe I can say. That's why I'm trying to take all the things in very detail, so you can see every possibility about this. Different index and head is, I think you understood where you are right now working, whichever the commit ID you're working is called head right now at this point in time. Index is nothing, is just information, right, in the staging area, whatever they know. Okay, is a complete information, especially staging area, which file we have, how many time we change, right? So this entire tracking that you do in the staging area is called index. So that is a reason sometimes staging area is also known as index. Okay, so either you can use the word index or staging area, they are almost the same. Okay. Mm. So Git Kraken, Ankit, tomorrow we'll talk about the Git Kraken, right? Very interesting tool. Okay. So concept of reset hard soft we will discuss today only. So guys, I'm trying to pick the questions that is more related to topic till now, because somebody was asking something that is going to cover in my next class today and tomorrow. So we'll talk about it. John, I think you're talking about Palo Alto use case with respect to Ansible training. So in Ansible training, we'll talk about, but not today. In my upcoming class for Ansible, I definitely talk about it. No, Satvik, technically, amend has no link with merge and any kind of conflicts. Okay, it is, you can think in simple way, whatever uh, data you have, or let's say comments you have, you want to change it. So there's no many conflicts. But what is conflict? I haven't discussed yet. Today, when after I discuss the conflict, you can understand the difference. So technically, amend has no as such, mostly no as such link with the conflicts, right? But if the conflict come up by chance, then you can solve the conflict the way you normally solve. But what is conflict? We haven't discussed yet. Today we'll discuss about the conflict, then you can use that skills over here. Okay. How to remove file from the commit area? This task, guys, I have given to you. Today I give answer to you how to remove any particular file from the commit area. Okay. I guess you can say, Amir, GitHub is mostly like Docker Hub, but perspective is different. The Docker Hub is used to manage images, and GitHub is normally used to manage the code, the way what we are doing here, right? So that's all, guys, right now. So, so okay, let's go for guys quick break. And after break of, let's go for 25 minutes. After the break, we will come back and see some more powerful concept of Git and then GitHub, right? So let me create one more scenario over here. The scenario would be something like this. So what I'm doing, let me very quickly create one more new uh, Git repository, right? So initialize workspace 30, 13, I can say, and there's a new, I'm just updating 13 over here. So this will be your new, I can say, the repository. Okay, so what I'm doing very quickly, let's create a file A, or maybe let's say create a multiple file in one go. 4 file we created, but maybe at this point in time, I want to add only one file in my staging area, and what a file I've added, I would like to commit this thing in my staging area. And guys, interesting thing is when you do dot means all the file that you have in the staging area, they commit. Okay. Okay. So mostly because in the project we have hundreds of thousands of files, whatever file you want to be commit and data you want to be commit. Okay, we normally use dot means put commit all everything. Mostly we use this. Sorry. But in this context, that will be in your control. If you think you only want to commit A only, put the A in the staging area. That's what I'm talking about. Okay. And I want to show you one more small thing before I run this. I have 4 file. One is there in the staging area. So if I run the git status command, you can see 3 file is untracked, is not there in the staging area. It is only in my working area. 1 file is in my staging area and nothing in the commit area. 1 file is yet waiting for to be committed. Okay. So normally guys, status command give you a lot of information here, but if you all want to have a compiled information in the simple compiled way, you can use S. So they can say you very clearly this question mark say this file is not yet tracked. A means the file is tracked, but it is been added in the staging area, but it's not yet committed. Okay. So this S option is something very useful. Now I'll do commit here and say all the file in my staging area, only 1 file we have in the staging area I want to commit over here. And as soon as we commit, your commit history created and you can see on the real time. And if you're in the status, you can see now this 3 file is not yet in the staging area. Okay. So anything that is there in the staging area will be committed. 1 commit we have done. Now, maybe my developer is working on B and we feel now we want to commit the B also. Okay, and this is the first time we are doing, I can say in this way. So we can again go and say add A to my commit area, also B to my staging area. So this 2 file is being part of my staging area. Okay, and then I want to do again 1 more commit. So again, this will be a quick revision of what we have done in my initial classes, but just trying to show you in other way, other angle with some extra options to you can use respective option as per your requirement, right? So this has also been done. Okay, and maybe my developer is working on the next file, new file they added, and I want to also add this file in my staging area, and I would like to add further in my commit. So my status is purely clean, nothing is there, everything has been committed. Okay, you can see the git show command. Okay, they will show you these are the files we committed last. Plus you can see you can use the head option here. Head will tell you the tree. Okay, so wait 1 minute please. So those who by chance know data structures, so in the data structure, we have a tree concept and every tree has a name and the name is the one who will tell where the tree is. So you can think guys, head is the one of the way to tell where the tree is. You can see from the graphical also. So head is the one, say, I know my tree. Tree means under me we have 1 node, then 1 node means child, subchild, and something like this, right? So head is the one who will tell that I am the tree. So if you see the help of this show command, they say, if you can tell me the path or the tree, I can do something for you. Okay. So for example, in the show command, if I had, they will tell something about this tree. For example, in the last class, I talk about show files only, these options, right? So I don't want to again repeat, but I just want to tell you, if you tell from this part only, if you can show me the options, I think the option was show files. Okay. Show files or show index. You guys remember, I think I told you those things in my last classes. But the point here is this is the structure we have created here. Okay, and if I run the git logs one line command, this is the information we have. Okay, this is the my tree or my timeline or my branch, or maybe I can say this is a master tree, whatever the name you want to give here, everything is right. Okay. Now here the important point here is, um, let's say I want to do further, and this is the last update we have done. It is there in the production environment. My our plan is to create one more branch extra because I want to add extra feature. So I would like to add a new branch that's called dev one. Why? I would like to add new data, new feature on it. Okay, let's say I want to add D1 file. Okay, then git add and then commit. Okay, so what's the plan, right? Let me first create this particular, uh, let's say D1 as a commit name. Okay, so what's the plan why I'm doing this? Because I want to create some extra lab here for showing you one interesting concept. I'm going to add all the files what I added here, and there's a D2. And let me do one more time. My developer also create some more code, some more changes they have done. They will add in the staging area. They will further commit. Okay. So this guys is how we create it. Now, in this case, the interesting thing is if you talk about the entire history, this is the entire history we have. Now, important point I want to tell you here is, okay, why we create a dev1 branch, almost the region is same. Almost the region is same. Whatever things I added extra here by my developer one in the dev1 branch, there's three history or three comments we added. So it's a extra history we added. Okay, every history we do something here, we do something in D2, we do something in D3, and let's say after after we have done all the changes here. Okay, I want to merge this guy in the master. Why to merge, you guys know. Okay, but the challenge here is, uh, again, upon use case to use case, requirement to requirement, having history is sometimes very useful. What I mean by this, when I merge, even though if I explain it from this graphical, when I merge, this entire history of day one will be added on the top of the master. Okay, means v1, v2, v3, entire node will add. Means in the master we have 1, 2, 3, 3 history. There we have 3 history, or 6 history will have finally. And what is the use of the history? We in the history, if you have B8, so we can go to at this point in time. If you have 6A, we can go to this point in time with checkout option or with some other options we have. Okay, so my point here is what I'm doing here. Okay, I'm going to merge. You guys know how to merge this, but before I merge, I want to do a small thing here. This is the workspace we created. Let me copy this folder as a backup folder, 13 into new folder, so I don't have to create again this thing. And because we are copying the folder is a Linux command I'm using here, and there's an option called R. Because we are copying the folder you have to create recursively. It's a pure Linux command, has no relation with the Git. Okay, this has been copied. So this entire diagram I've copied actually, so I can use one more time. So in 13 workspace, we are in. Okay, so let me go to my 13 again. And you know what I'm trying to tell you here is when you merge, let me go out, workspace 13. Okay, so when you merge, so how you merge, you first normally go to master. Because I want to merge in the master, we'll go to master first. And when you merge from dev1 branch, so entire history of dev1 branch, what we added, exactly history copied here. So we see here, exactly same history they copied here. Master has 3, now master has 6 history. Okay, So if I show you the history on the master, what you will see, the entire history copied here. This is from master, and this three D1, D2, D from dev1 branch now is a part of master branch. Here, master is pointing to this. It means everything come in the master. Okay. Now, guys, upon what I'm trying to tell you here is, upon the use case to use case, sometime I want my developer one entire history copy to master. And one of the reason is, if you have the copy of entire history of dev one, so I can go to any point in time. Okay, I can check what has been changed by developer here at this point in time. So I can say git show me, okay, what changes they have done here. Okay, test. So we can say at this point in time, my developer one, okay, added this comment D1. That's what they're showing you here also. Plus they added new file, some new file they added over there. Okay. There's one more thing I show you guys, when you can see the content also with cat files command. So having the history has a benefit. Okay. But sometimes having this entire history has no meaning. The unwanted increasing your history size, because bigger the history size is harder to search, harder to find what we are looking for. For example, okay, for example, a developer has created history and they keep on doing changes and they keep on committing the things. And after doing thousands of changes, they commit and finally they create a final feature. Okay. So if you merge, then all those thousands of history will be added on the top of master branch. The next master branch history is so big. Okay. And if the history is very big, is very big, so it's very harder in the terms of management. Means if I want to go here and there, I want to go to particular version, I have to search with time, I have to search with the name and lots of, it would be very harder. I'm mainly in the context of history management. Okay. So what I'm talking about, while merging, you can take a decision. The decision would be something like this. If you think what a developer one has done, multiple history they created and versions they created, I don't want to take the entire history from the developer. I'm only interested, okay, whatever the changes they have done, I want to take only the changes in the terms of file, in the terms of content. That's all. I'm not at all interested in the history of dev one, dev, and their comments, other things. Okay. In all these three changes, whatever the content they changes, for example, they have added these three lines or three files or some content we added in this file. I won't have those content to come in my master branch. This called merge. But I don't want the entire history, come up in my master branch. Otherwise, it would be big trouble in the form of managing the history in the master. Okay. Technically, it's not giving the trouble in terms of storage management, because storing the history won't take much storage or the hard disk or the RAM, but only the challenge would be in the terms of management. Means if I want to go at one point in time, huge history come out, thousands of thousand lines, very hard to go up and down search, so tedious to manage, right? So that is a reason, guys, that is a reason we have one concept. What can we do? Instead, we take this entire history and copy in the master. What can we do? We can say this guy, I'm not interested in history, I'm interested on your content. What content you change here, here, and here, and finally what are the final version you have. Take this entire data and add on the top of the master. Okay, and obviously we are adding something new on the master, then this guy will have a different commit over here. Okay, so instead of this 4 and 5 and 10 different changes history come to me, final version whatever you created, I'm only interested on those content and those files. Take the entire content in this new commit inside the master. So again, we are doing merging. It is exactly like merging. Same content is coming, data is coming, code is coming, but I am not taking the history of the dev one. Why? I will explain to you. Okay. This concept, guys, is known as merging only. But in this merging, we have to use a kind of, maybe I can say some kind of strategy or some kind of way of management. And this management is called squash. So we're squashing, okay, or squeezing, maybe you can say, this entire history and make it one single history. Okay, so it will be good in the terms of management of the history. It's something very useful concept. It will help you a lot, okay, in the bigger project. Otherwise, your history becomes so big, harder to manage. Okay, so that is the reason I have created one backup file of WS workspace. I'm going to WS14. Okay, so I can show you this demo, right? So what I'm doing here, I'll go for different workspace that is called 14 here. Okay, and what I'm going to do, this is the entire history we have. There's 3 versions. Dev 1 has changed. So if I just go and check out the master or switch to the master, and if I run the git logs command, right now master has only this 3 history, but I want to merge. But what do you see, guys, this time? When I merge, okay, when I merge, git merge command of dev 1, but this time I'm merging with the option called squash. Very interesting option, useful also. Now, if I do squashing, what you will do, what you will see actually, okay, now CEBA B9, this history of dev 1 won't add in the master. Okay, even though without squashing also, if I show you, I have these 3 files. But now the file of dev 1 comes to me. But as soon as I merge with this squash, okay, from dev 1 branch, again they are doing fast forwarding, because this is fast forwarding merge. But the interesting thing that you will see here, they are doing squash commits. Okay, nothing you can see here. Okay, but your data come up here. So technically what we are doing, we are pulling the entire data from dev 1 and put in the master branch. See, guys, this data was not there in the master branch, but we pull from the dev 1 branch. that's called we merge in the dev 1 branch. Okay, and after merge, the history is not yet copied, right? If I again show you the logs command, history of dev 1 doesn't come up here. Okay, but if you run the git status command, now you can see new file come up in the master branch. So technically it is, you can think in this way. Okay, in very quickly, the concept perspective. So all the changes you have done in the dev 1 branch, we pull those changes and put in the master branch, where in the staging area only. That was they're talking about. These 3 files will be added in the staging area. Because it's not yet committed, and because they're not committed, that is the reason there's no one more extra node created. Okay, so this is what they're showing you. Data is there because anything come in the staging area, first they have to copy in your working area, and because they copying in the working area first, this is the file come up here. Plus they also add in the staging also area. So this file added in the staging area. Okay, now if you want to have this part in your master branch, so you have to do one commit here of all those data. Well, let's say squash merge, some name you can give. So I've committed. It means technically all this file, or I can say the entire history, not history, the data that dev 1 has changed has been added to the master. Okay, and where they added, technically look like all the CE, BA, B9 3 history has been copied in 3.4, this new one. How? By this command. This is how it was. Very powerful concept, very useful, is squashing concept. In the GitHub also, we have this option. I'll show you. Normally or mostly we do sometimes squashing there, okay, instead of the merge. Okay, but this is guys called merge with squashing. Okay, so now my history is, there's nothing to commit. We have a data come up from a dev1 branch. Okay, and plus if you see the logs also, only 4 we have. Maybe guys, this in this particular point in time, lots of data come to us, a lot of features come to us, but from the dev1 branch, and that dev1 branch might have hundreds of thousands of history, but everything is squashed into one. That's the idea of squashing, useful. And after this, we don't need any dev branch. We can delete the dev branch, because whatever they have done changes, we already merged into the master, merged with the squash, so we can change. Okay, very interesting concept, guys. Very interesting. This very interesting scenario, I can say. Okay, now because we have done squashing, so they become confused. They say dev1 branch data is not merged. Okay, but actually we merged. And why they're saying this? Because you're trying to remove the dev1 branch, and they see in the master branch this CEBA B9, this history is not available. So that is the reason they think it is not merged, but it is merged because we use squashing. Because in this squashing, we don't have to copy the history. So this is in this command confused, that give the error, but it's not the error because you have done by yourself. So you know the concept, what you have done, and you're pretty sure the entire data has been copied. And because you're sure, then you can delete this branch forcefully with the option called -T. So you can sure if you want to delete, you can delete this with the option called -T. Okay. So now this branch has been deleted. And now we have nice clean history. And this again, the case, because this data is, this CEB and B9 is being managed by dev1 branch. So dev1 is the head, or dev1 is a branch where these guys are managed, these node are managed, but this branch deleted forcefully. So these guys become unreachable, or they become orphan node. Okay. So these guys we can't see from the logs command, orphan nodes. Okay, so CEBA is not visible, but if we use the reflog command, we can see these guys exist here. Okay, CEBA, CEBA and B9. So if you want to use, you can again check out and start using somewhere, connect to somebody with a checkout command. I show you already. Or if you think now everything is done, check out and data copied and merged, so you can clean it, right? How you can clean with a with a GC. So I can say git, just use your garbage collector, and I want you prune the data till now. So whatever the orphan node you have, unreachable node you have, go and prune it. Okay, it means just remove this node permanently, right? I don't want this guy to be in my commit area. So they do. But this time you see, guys, nothing is changed. Okay, because GC guys behind the scene doesn't know which part to clean to take a garbage collector. And that is one of the reason, because I just run this command first. That is one of the reason we have to first use this expire command. So the command that I showed to you already. This expire command. Okay, what this command will do, they will go and check all the unreachable node till now, all. Internally they tag something that now these are the expire node because they are unreachable. Anything that are unreachable and now become expire. Now this time if I run the GC command, so this will check whoever the expire is, and then there's been the git has been tagged somewhere, they will prune. And after the prune, you can see this will be removed from the committed. Okay. Now you will see guys, they have been removed from the commit area. Okay, I just want to revise this command one more time because not some of the guys has it, you know, understandable. You know, they wanted to again discuss, so I just will explain you one more time. Okay, but guys, this is the concept of called squashing one topic. Very important concept. I explained you with the use case, and it's done. Let me create one more scenario here. The same example. So what I'm doing here, right? Let's say let me add one more new file, and let's say file would be n1.txt. One file we added. Okay, let me add into my staging area. Let me add this file, and let me comment this file. What we have in the staging area into, let's say, new file one added in my commit area. Okay, the new file will be added. So 6C 8A will have this new file non n1, and my commit name is also n1. Okay. Now, this point in time, my history is clean. My history is clean. Okay, nothing to add. Let me add one more file. I want to show you something. And to add n2 in my staging area, and one more comment I want to add very quickly. Let me add one more file to create particular, you know, real kind of scenario I'm trying to create here, and n3. Okay, so this is a history we have created. Okay, now what I want to do right now, my status is clean, nothing is to commit. It means whatever data I have in my working area or name or repository, all the file has been added into the staging area, and then they go to the commit area. Or maybe we have an ignore file, some of the file may be ignored. So it will be anything, but technically my status is clean. Okay, clean. And we have these many history we have, or maybe you can say these many history we have right now. Okay, now what I want to do here, is whatever data I have at this point in time in my history. Okay, or I can say in my commit area, I want to take this data back to my staging area. Again, I'm repeating. Okay, last time guys, I added n3.txt file. That's what I write the command name also n3. So whatever data I added, okay, in this commit area, I want to take this data out from my commit area to the staging area. Okay, that's what the plan is. Okay, so technically I'm asking my my commit area that I want to reset you. Okay, I want to change on you. Maybe you can think in this way. Okay, so means whatever data you have here in the commit area, I want to take it out and put in my staging area to make you this concept very clean. Okay, let me explain you in this way. We have a working area, we have a staging area, and every area use, you know, water data. We have a commit area is like a backup. We can roll back, we can go here and there. And whatever data we have the commit area, okay, those data only will transfer to the GitHub, and those will, the area will transfer to other branch. Okay, so the commit has a lot of use cases. Okay, staging area, you guys know, to track the files, other things staging area do, and working area where we as a developer or software developer work here in the working area. Okay, but right now all the data is there in my my commit area, okay, as a backup copy or as a snapshot. Okay, so what I want to do here, I want let me run the status command one more time. Everything in the commit area, because they are clean, my tree is clean, nothing to commit. Okay, so what can we do? We can tell the git, all right, that there is something in my commit area, I want to take it out because so sensitive, because this is one file, let's say the n3.txt file is there. Okay, if I don't take it out in my staging area, so what happened, as you start push the data to GitHub, this data also go to GitHub. But this file I committed previously, but I thought there's some bugs here. I thought there is something to be done more. Okay, so I don't want to take this risk here. So I want this file again come back to my staging area, and obviously it's coming to staging area, it will be removed from your commit area. So by chance somebody do push and something happened, create a new branch, this data and this file won't go to my GitHub. Something like this. Okay, now it's one single file, or maybe whatever you done in the last comment, it will be everything, right? So that's what you can mention here. So we can tell my Git that I want to reset. So okay, I want to reset, okay, my last commit, and last commit is known by this number, or you can use by head, whatever you would like to say. Okay, we'll go to last, but technically you don't want to go here. Last would be this one, because this is what changes you have done, you have already committed. So you want to go back, this will be your last. So you can give this number, either you can do in this way, or you can use tilde one is the same thing. Okay, because current node or current commit is known by head 0. Okay, second last one, either you can use the name 97, but this name is always changed in every repository. So better would be one I can use. What is this? I told you in my last class. Okay, so we are resetting to this node 97A5. It means my head is pointing toward this. You can think in this way as a logical perspective, but technically what they're doing, whatever data you have at this commit, you have 10 files, 20 files, some file edited, some file removed, everything will be rolled back kind of concept over here, and we move to end. Okay, we move to end. So after we run this command, now you can see guys, this visual is so powerful. Now my head is now moved to 97 here. My head master moved to 97 in the graphics, and this guy is not yet connected to anyone. So they become the unreachable. We can use it with the checkout command. There's a different point, but it has become unreachable. Okay, but in this case, what happened? In this case, what happened? Okay, what happened? Now, if I run the status command again, you will see, okay, your file is now come back to your untracked file. Okay, untracked file. So when I use this option, what happened? They say now file is untracked. Okay, means if I run the status command have as, means you can think it is something like this. This is the file is not known by Git yet. Okay, now it's coming back to your working area. Okay, so this file come back. Technically, guys, this example by chance is a little bit different example. In this example, what happened? What a last commit has done. In the last commit, guys, we have copied this file. So this file is removed from the commit area. Plus the tracking of this file also removed from my staging area also. Again, this file come back to your working area. Okay, and it look like this is the first time we have seen this file. The file is not yet tracked. This maybe it look like this is a new file you have created. You as a developer still working in your work area or working space on this file. Okay, and even though see the git one log, one line, get log, one line. Now you have been pointed to this, but the last committed that you have done was this one, it removed. Why I want to do this? Because I accidentally put in the staging area or my commit area, or maybe after putting the commit area, I come to know I wanted to change in this part. This commit area I want to remove, or this commit object or commit ID I want to remove. So you can think in this way also. If you want to remove the commit ID, what we committed last, this is also one of the way you can think of. Okay, so now it's come back as a normal file the way you added initially. initially when you add a new file, they show you this symbol question mark is a new file. In this new file, whatever changes my developer want to do, they open this file, they put new data after changes, okay, where they put, and then they will add again. After the add, they will again cut. Let's say M3 new data. Okay, and after the commit, sorry, is again. So technically, what we have done, we initially created D600 commit area. We remove this commit area. We can come back. Everything come again in this initial go. That's called working area again. We do some changes again, put in staging area and then commit a new history created. And now this become again orphan node. You can guys know how to do a GC garbage collector to clean this node. Okay, but in this case, if you have this kind of requirement, what is the use case I'm talking about? In this requirement, we use reset, and this kind of reset is known as mixed reset. So either you write this or you don't write this. This option they have also mixed reset. Okay, so this example is known as mixed reset. So if I show you one more time, okay, so in my logs, this commit ID contain new data. That means they contain this file with the data. It means if I do git push or if I do git check out new branch, let's say dev one, entire data will go to dev one. This also go with the content. With this content. Okay, but I don't want, maybe I don't want this commit will go to my other branch in the git push also. Okay, so that's what we wanted to do here. I want to reset and take my data back to my working space. Okay, so let me very quickly delete this branch. Just wanted to show you. So I don't want this data will go, or I can say in the simple way, I don't want my last commit will go anywhere. Okay, I want anything we push or we create a branch, they will take this data. I want to again wanted to work in this part. So for this we do reset. Okay, but this reset is called mixed reset. If you write or if you don't write, by default reset is called mixed reset. There's two more type of reset we'll discuss, and we reset back to which position. They can decide to do 1 history back, 2 history back, 3 history back. Maybe you want to reach here. That will be your choice. Okay, let me go to 1. Okay, so by default is a mixed reset. You go here. Your head will go here. Okay, and now what you have here, if you see the status, this will again come to your working area. Work on this file, again add and commit. That's what you can do. So this is guys called mixed reset. There's one more kind of reset, it's called soft reset. Let me tell you, there's 3 different kind of reset we have. Okay, almost they're working in the same thing. Anything that you add in the commit area, and from the commit area you want to take your data back. Okay, obviously where, either in the staging area or in the working area where you want to take it back, that will be your choice. But anything that you committed, you can go to any commit ID. Okay, and that part you want to remove from the commit area or want to take back in these area, either this one, the way it is, that is not been committed, right? Then we have used reset. Okay, one of the reset that I showed to you here is called mixed reset. What mixed reset do? They will remove all the thing at that point in time of my commit ID, remove from the commit area also, or they remove from my staging area also. They remove from here and they also remove from here. Okay, so at this point in time, what are the commit ID I'm using here? Maybe ID, or maybe I'm using head, last 2 Okay, that reference or pointer at this point in time, what a file we added or what a data we added, they remove from the commit area, plus they also remove the tracking from the staging area, and they come in the working area as is. And so we can start working from there. That is a idea of this mixed reset. And now, because if you see the logs also, okay, so we are pointing to N2, means here. Now, in this case, if I do git push, if they're pointing to 69797, if I do git push or git new branch, only this data will come there in the new branch. For example, if I go to dev1, dev1 already exists. If I go to dev2, in dev2, only data that exists till 97A5 will come here. Yes, 97A5 come up here in their commit area. But this is also visible because it's a part of my working area, because this file is not yet committed. So this file is again just. So it's like a working area actually come up here. But this file is still not the part of my this branch. Okay, but these files are the part of my dev2 branch. Okay, so my dev1, dev2 is a feature branch. They work on this file, they commit in their branch, or they merge, or we directly work on the master branch. We edit, we put in the staging area and then commit. Depend what's your plan for further management you want to do. Okay. But in simple term, I want my data in this time or in this commit ID. I want to take this data out, okay, from here and from staging area also, and put in my working area. That was the whole purpose. Okay, so there's one idea. Now we have some more kind of reset depending on the requirement. Let me first go out. Let me switch back to my last. There's no branch expected got commit because nothing is committed. So let me use this command for checkout to go out to master. The thing is, there's some file has been untracked in the working area, be overridden by this. So before switching, you just remove the file to switch. So better, let me add also. Better than remove, let me add commit dot m dev2 dev user 2 added this file m3. Let me switch to master or here. Now what I'm going to show you here is okay. First, let me clean this entire data so I can show you very clearly. So let me clean this entire tree or my repository. Same thing. Git branch. I want to delete dev2 branch forcefully. Okay. And I also want to delete this branch dev1 forcefully. Okay. Then to clean, there's some orphan nodes we have. So I will call this expire again, and we'll call GC collector, garbage collector again. So everything is now very much clean. This is the data we have. Okay. Now what I want to do here, so this is the data we have, and everything we have in my commit area, everything is clean, nothing to commit, everything is clean, nothing is to commit here. Okay, and we know we have added some new file here at N3, here we added N2, here we added N1. Okay, and all the data is there in my working area. All the data is also there in my staging area, and internally they are stored in my commit area also. So again, I want to do reset. Again, I'm resetting back to my one history back. So this is 0. I want to go at this point. If I hit enter, they will use mixed reset that I will explain to you. Okay, but instead of mixed, I want to go for soft. So we can pass the option called soft. So if you don't pass an option, by default option is mixed, but you want to go for other reset, you have to use soft. Okay, so what soft will do? You guys see here, my nothing to commit, nothing is there in the staging area to commit. Okay, and all the files in my working area is already there in my staging, oh, sorry, in my commit and the staging area. Okay, but if I do this thing, okay, soft reset, if you see here, okay, first of all, my head start pointing to 9797, second last one, because I asked them to reset to take me here. This is one thing. Okay, but what soft do extra what Mix is not doing? Okay, so in this case, right, if you run the status command again, in this case you use some difference here, and the Mix, they were showing you question mark, but here they're showing you A. Technically what they're doing, if I run this option here, they are remove this data from the commit area, but they put this data into the staging area. Okay, that is what, guys, the soft reset is doing. So they say, I'm putting your data back. If you do soft reset, I'm putting your data back, remove from the commit area, but data would be still exist in the staging area. And because they're still put in the staging area, it means some of my developer working on this file in the working area, adding the code. So I know how to track this. For example, I know because this file is there in the staging area. You guys know use of staging area. If I add something and somebody adds something in this file, let's say new test, they added. Okay, so we know how to track this file. We can say this file has been modified. Okay, because this file is staging area, we know how to track this because we're tracking, so we know this file is modified. Or you can use S option to check this file is AM. A means it's still there in the staging area, is not there in the commit area. M means it's still in the staging area, but somebody in the working area has been modified. So this is called AM flag. Okay, so guys, in my initial class, I talked about in the staging area, we maintain multiple flags. So these are the flags. A means this file is added in the staging area, but not in the commit area. M means this file has been modified. Where? In my working space, or work area. Okay, or maybe the working area. Okay, so this is what, guys, they are doing. And why we want to do this? Because I don't want to keep this file in my commit area. Because if we put this file in the commit area, so what happen if anybody push the data, this file will push to the GitHub, or anybody do a checkout and get new branch, this data also go to new branch. So I don't want to share this commit history or this commit data to anyone. Okay, I committed initially, maybe externally, or we committed like with nothing technical reason, but we committed. So I want to take the data out, so that somebody will push, so it won't go to GitHub and some other places, or it won't go to my production environment. I want to do more changes in this part. Okay, so that is the idea. But if you think you're good to go, just again, because now there's no requirement to add. Okay, requirement to add this file, so we can actually go and commit this file. It's already there in my commit area. So N3 added after soft reset. This is the one comment I'm doing here. Edit. Now everything is clean, nothing to update here. And if you see the logs history, now this one committed, new commits come up, right? And this again, there's no use of this because we already reset this guy. So again, you can call expire to expire that is not reachable, and then ask the garbage collector, go to my commit area. Anything that is not connected has been tagged expire by ref log. Just go and clean this part. So guys, this is what the reset soft is doing. Guys, according to my knowledge, if you see any of the videos in YouTube or some other training or in blogs, this topic is very confusing, right? I'm just trying to make this topic very clear to you with the right use cases. Main thing is in which use case what to use. That is the main thing, right? Otherwise, resetting anything like reset makes your soft it look like same. But if you understand this concept, what I'm trying to explain to you, that makes more sense. Okay, so rather than you memorize this mixed and soft, you just think what you want from the commit area. I want to remove the file, plus staging also you want to remove the file. So I don't want to track. I want to give a flavor that is like a new file we have created, something like this, and then go for mixed. Or this use case, you want to just remove from the commit area. You still want to track the file in the staging area. It is something like this. We have done git add kind of command. So that kind of flavor they give to you. Okay, and after everything done properly, then we can commit in the future. Okay, so that is if you know this concept, then properly you can use when to use soft and when to use next. Okay, and then we have one more kind of reset called hard reset. Okay, very dangerous this one is. Okay, what I mean by dangerous? Okay, so it without using properly this option, it will create a lot of mess in your working area. What I mean by this, so right now everything is clean. Okay, this file, all this file data is there in my commit area. This file data is also there is my in my commit area. Okay, this data is there in my commit area. Okay, now this is a working area. This folder is working area. My developer is working in this file, and let's say they added some more new data in this file. Okay, let's say new data by some data they added in this file. Okay, and because this file has been tracked by staging area, so they come to new data has been updated in this file. So if you run the status command, so they say the file has been modified, because we are tracking this file in the staging area. The staging area say this file has been modified. So if you want this file to store in the commit area, you can commit it the way you commit. But here the requirement is different. What I wanted to do, okay, what I want to do, whatever data I have in my commit area, I want to remove. That's what the reset means. I want to reset my commit area. Okay, or in simple term, there's some commit IDs I want to remove. Right? This is also one of the way you can think of. But technically it's what reset. I want to reset my commit area. Okay. But if you use the hard, what happened? Okay, so right now, this is my current status. Okay, and this is the my log history we have. Okay, and let me show you my graphical also. Now, if you do reset, okay, again, I'm going back one head up. That's this called one head back, I can say, or one head down, maybe I can say, to this guy. Okay, with the hard. Okay, what happened? Now your head is now connected to this one 97, one head down. We ask one, same kind of look and feel you see in mixed and soft also. Okay, but in this context, if you again see the status, now status is cleaned, and this is very dangerous. That is one thing. We reset, and after reset is clean. But even though guys, in my in my soft reset, okay, in my soft reset, when I have done where I have done the soft reset, right? I don't know. So they show this option. If a mixed reset also, they show you something is not clean. But if you do the hard reset, you know what? They're showing after doing hard reset is being clean. Means nothing to commit. Okay. So you know what I'm talking about, what they have done. Okay. And why they are very dangerous. All right. If I show you here why they are very dangerous. Okay. If you just look at this diagram or this page, what hard reset have done. Okay, whatever changes we have done at this point in time. Okay, and whatever change we have done at this point in time, we know the difference with the differential command, because there are different snapshots or copy we have. But whenever you do a hard reset, okay, this commit data, what we have at this point in time, let's say this is a one, and let's say this is two. So whatever commit data we have on the one, they compare with the two. This is called differential. Okay, and what differential we have, it means those things we have changed. Okay, so what hard reset do? Hard reset will go directly to your working area where developer is still working. They are developing the code, maybe right now in the real time. A lot of interesting things they've added in this working area. What they do, they will go and remove all the differential directly on the working area to give you illusion that that has not yet been added. So what is dangerous about it? Let's say I'm working directly in my working area and I'm doing some code, I'm writing some features, one new function method classes I've written in my code, and somebody accidentally run the hard command. What happened? All the things that I've done till now will be reset back directly in my working area to this point in time. So what did I had at this point in time will reach there. Means all your current working we will lose, or you lose your current working. You won't get it back. Okay. That decision is very dangerous to use, but sometimes useful. Sometimes useful. It is something like this, like kind of rollback, kind of rollback. Okay. Because maybe as a developer, I've done a lot of changes. Okay. And those changes, I'm not happy with this, or my command, my programming working has been corrupted, maybe. So I want to roll back my working area, okay, and reset my working area at this point in time. At this point in time, so I will say, see my code what I have at this point in time. For example, at this point in time, I don't have n3 files here. There's no n3 file. So this n3 file removed from here. Even though I changed a lot of things in my n3 file, but this entire file been removed. So at this point in time where I reset, all right, that file was not exist. So they removed entirely from my working space, so my current directory or my repository. So if you want to see the entire look of this that point in time, okay, in your working area directly, you can use. Okay, but guys, in the soft and hard, it won't work in this way. They are not touching your working area. Neither this guy is touching your working area, neither this guy is touching your working area. Whatever you have in the working area right now, at this point in time, we're doing mixed and soft. They're not touching your working area. They're only removing data from this commit area or maybe from staging area or not. Okay, but hard is actually removing your data from the commit area, removing data from staging area, and also removing from the working area. It means there's no backup copy of it as such. Okay, there's no backup copy of it. Plus, my developer is working maybe in the ID, some of the developer tool, entire data will be removed, flushed off. Okay, if you want this, maybe sometime you want. One of the example is something crashed, code is not working, I want to roll back as entire backup, like undo kind of thing, right, of entire project. So hard reset is good in those part, but accidentally, if you've done the hard reset, sometimes I've seen a lot of guys are doing this practice, is very, very bad practice. Okay, don't do this, otherwise you will lose your data. Okay, that's one things. And because they remove the entire data from the working area, that is a reason there's no issue in the status, because the file is removed, nothing is visible, nothing to edit, because everything is rolled back. So there's no meaning to have any issue with the status command. None of the status flag is commit and question mark and like a modify, because it's removed. That was the reason they show you very clean status here. Okay, so there's all these three reset I explained to you with proper use case and practical, but is very, very critical to understand when to use what. Okay, and because we have the versions, multiple snapshot, multiple commit IDs, we can reset any point in time, depend how and what kind of reset you want to use. Accordingly, you can use. Okay, that's one thing. But hard reset is very dangerous, but because of the internal management of your what I say of the Git, I can say, okay, because whenever you reset, you go back to 1 or 2 or 3 head. Okay, you go down to particular head, and those node is not internally deleted. Okay, internally deleted means this node is unreachable but is exists in your staging area. This node is DBB, is not a part of your tree or your head or master timeline. So you can't see this node BDDD in your BDD, DBBD or something in your master timeline or master branch. But Git Git keep this node with them. One of the reason is to save ourselves from accidentally reset kind of thing. Okay, so Git say if somebody have done accidentally this reset hard, you will lose your data. That's what I've done. You lose your data from your working area. In this case, you should have something who will help you to reset again. Maybe this was what reset we have done accidentally and I lose my file, but I don't wanted this, but accidentally I've done this. So this unreachable node will help you. And that is one of the reasons why we don't mostly we don't do garbage collector automatically. We have a concept in Git where we can run garbage collector automatically, means this one automatically as soon as something goes unreachable, do the garbage collector. But if you do the garbage collector, this will remove. And in this case, if something accidentally happened, that's what I'm talking about here. Okay, then there's no way to get your data back. So good practice is, again, depend upon requirement to requirement. If you think this kind of scenario might happen, so don't run this garbage collector. There's some technique that garbage collector automatic run always. So don't run automatic. These two command is take a practice, just run by yourself manually whenever we need it. Okay, or we can schedule this thing also. This come by some kind of job schedulers in the market and say run this command every 1 hour, 2 hour, or 10 hours. So that's the different point we can do. Okay, but interesting thing is, let's say I have done my hard reset, this one accidentally, and my data will remove from all the areas. My N3 file is not there. So how can we get back this file? Okay, so we have this node available. So what can we do? This is the command I show you. Now we can take the power of checkout command. Checkout, I say this BBD46D, this information we have. I want you take my head to this point. So the head will go to detachable mode. Now head will go to one of the node that was unreachable. Okay, so this head come, and as you reach to this head, you get your data back. You get your data back. Okay. Now in this case, but normally head is just a pointer that will tell you the current point. After I close this my system, open the close my terminal, again you connect to master. Or maybe reboot my system, they connect to master. If you go to other branch, again to come back to master branch, they again go to master. This node will again become unreachable. For what I mean by this, okay, let me very quickly go to some other branch. Devon branch, your head will go to Devon branch. Yeah, Devon branch. But if I again go back to master, sorry, master, you again connect to master with this 975. Or maybe Devon branch, somebody want to remove, maybe I want to remove forcefully. Again, this become again unreachable. So what I'm talking about, okay, checkout option on particular commit ID is temporary. Again, head will again go back somewhere else. So that is the reason right now you don't have a data of N3. Okay, so when you do checkout or connect to this particular node, data will come up. Okay, but you have to make this data permanent save, where maybe you want to save in the master branch. So how we can do this? Simple, right? After head come up, we can store first this data, Okay. Even though if I see the git status also is this point in time, git status. Okay, everything clean because everything is committed. It's also committed. So it's clean. So, but my point here is what I wanted to do here. I want this data to be stored in master permanently. Okay. And normally you want to store in the master branch, you have to commit, but nothing to commit here. Okay, everything is clean committed. So how to commit? Okay, nothing to commit. So in this kind of scenario, one of the simplest ways is to just again create one more new branch. Let's say dev1 branch. And you guys know when you create a new branch, all the data where head is pointing to go to dev1 branch. So technically, this data will go to dev1 branch. Okay, now we are in the dev1 branch. You can see get log one line. So this branch have this data b d b b d. This data they have it. And you guys know whenever any data come in the dev1 branch in that tree, you can merge back into master, not big deal. Now I can go back to again master and say master, I want to merge some data from dev1 branch. Again, they merge back. This data again come up. Now you're on the master branch, you can see your data is still there. So it's small thing is very useful, you know. Sometimes accidentally happen, right? And it's not a small thing. It's very critical, right? Because you might lose your very powerful code and concepts and logics, right? In doing some kind of reset or hard reset. Reset we need to go back, see what happened, right? But accidentally having wrong reset will create multiple challenges. So you should know the approach. So I just explained the entire approach, the challenge, then how to resolve this. I also explain you that point right over here. So this is the one quick idea and information to you. Okay, so I explain guys this reset concept in very much in detail. One more concept I want to explain you more look like this, but has a little bit different use case. Let's say this is my N3. Okay, file. In this N3 file, let's say I want to add some data. Okay, let's say B1 new data I've appended here. I appended, so let me commit this data with B1. Okay. So why I say B1 so is M. Okay. And now let me add some more new data in this file as a B2. Okay. And again, I do commit here. So everything is clean. Nothing is here. It's been clean. Nothing here. All right. So what I want to show you here is whatever data you have in M3 file, okay, in your working area, exactly same data you have in your commit area in 067. Okay, that's what you have. Now, what happened? Maybe let's say I want to add some more thing in my N3, or let me open my file N3 with some text editor like VI, and let me delete some data. Add some new data. So I added some new data. I'm doing some coding change here, code change here. Obviously, this file modify. You can you know, store this, commit this file again in your work commit area. Sorry, okay, from the working area. But maybe at this point in time, this file, whatever the code I want to change, is been corrupted. I don't want to use this code. I want to reset my code. I want to roll back my code. Okay. And now you decide you want to roll back at which point in time. You want to roll back at 067 or DD82 or BTD4 97A. At what point in time you want to roll back? Okay, only this file. Okay. So, or maybe you can think in this way. This file has been corrupted. Okay, in my working area, and this file is still modifying my working area. I want to reset because what I did, at my last commit, I store my file in 067. That was perfect. So it is something like this. You are doing your code. Okay, doing your code in some kind of text editor. Okay, and what is code you want to do? You change. You want to undo the entire code till the last person. This is very common use case where the developer, wherever you commit, normally we commit always after successful thing is working normally, and mostly I can say. Okay, and then start working on the code and something is not working, you want to be able to figure out the challenge, what and which part of the code my thing is not working. So one quick thing you can do, you can reset or undo the entire code till your last commit. Okay, so this is a working area, you have to commit to last commit. So for this, again, we have a git checkout command. That's what I'm just talking about. And just give your file name. That's it. Just give your file name. So what happened when you give a file name? Okay, so what they have done only for this file. Okay, guys, see here, nothing has been changed in my tree. Nothing, none of the node go the way you see in your what I say, in your reset things. None of the node become orphan. Okay, what this checker has done. Okay, whatever change you have done in the working area, that has been removed and they've been reset back to what you have done in the last commit. Means this is the data we have changed and updated. Now this data has been resetted or updated to your last one. This is the last one is the same data what I committed at 067. Okay, and this data was the one who was working fine perfectly at that point in time. So we reset it back, and after we reset it back, these guys, now again I start working on my projects further. So checkout is a great option. Multiple things they do. They get a branch, do something on the branch. They take you ahead some point in time. Or checkout will also help you in this context also. Multiple things. Checkout is useful, very powerful command. It is. Okay. There guys, one more very powerful use case. This is a very common use case. We keep on using this command again and again. Okay, to reset our entire code back to the last commit. This is what and how we use. Okay, so this is guys, one more thing. Let's quickly go to GitHub and do something on the GitHub again. So what I'm going to do, I'll go and I'll just create git init, and in the git init, where it is, git init, let me create one more new workspace, 15 new. Okay, and what's the plan? So plan is something like this. Now this repository I want to sync with GitHub, that you guys know. Very quickly, let me do it. Okay, so this is a new repository, and in this new repository, okay, let me create some new file, cat a.txt or some data, and I would like to add this data in my staging area. Then I want to commit this guy in, let's say, command called FFF or AAA kind of commit. Okay. But this file is there in my working area. I want to sync this file with my what I say, to my GitHub. So how we do, we go to GitHub and create new repository. The way how we create, you guys know. So there's a git training, spelling might be wrong, test 111. Okay, near be creating publicly. I don't want to initialize over here because it is already created locally. I want to sync with this guy. I don't want to initialize. We discussed already in the last class. Okay, for sync, the guy say is going to create this thing. This is what we have done already. Commit we've done already. Okay, branch we already have. We have only do this with SSH. Well, last time, guys, we have done the SS setting. So I will run this command. This command I will explain you guys in my last class. So right now in my remote, I don't have any remote setup. Okay, best. So remote setup has been done. Okay, they say whenever you do push, your data will go to GitHub at this particular account and this particular repository. Okay, but which branch you want to send, you might have multiple branches, but I want to send my master branch, so I can write this command. The guys, I explained in my last class again. So my master branch go to my origin. Origin is the information of where you have your URL. Okay, I'm pushing this thing. So origin will be my upstream. So that this concept I explained in my last class already. Okay, this is uploaded, and that's all. So this concept we have discussed. Now after we refresh, thing will come up. So till here and lots more other options we have discussed in my last class. Okay, but what you see here over here in your graph, they are very clear. So they're also showing you now at this point in time, this 567 is being connected to local master and origin master. So they will show you both thing here. Okay, so 5 FC5 is connected to this origin. GitHub is origin. They show you here in this visuals also. Okay, now what happened? Right now my Git status is clean. If I do some more changes in this file, okay, we can say the status, something is modified. Let me commit. Okay, and guys, when you do commit, they commit always in your local system. Okay, so now from here, it's very clear my local system is one version ahead of the origin. Okay, so this status say nothing to commit, but if you run the status command without S, right, where S only show the flag, they're very clear that your branch is ahead of the master by one commit. Okay, master origin means the GitHub. Okay, so in this case, what can you do? You can do push. So for pushing, you don't now you don't need to use this option again. One and initially you have to use, because after you have already done, they will maintain internet. I'll show you the command in the last class. Okay, now you have to do just git push to send this guy. So last version was one commit and a push. So this is also updated here. Now GitHub and local both is going to 6B. So if you go to GitHub, okay, and if I refresh here, you see both the guys will have a same 2 commits with 6BC, same thing they have. So this is the scenario. Okay, this is a scenario where, okay, where in local system you're doing some changes and then uploading into the GitHub. Okay, but there's a possibility that somebody is directly working on the GitHub doing some changes there. In this case, okay, if you're doing changes here, so if you want to sync with yourself, then in this case you have to download this change in your system. That's called pull. Okay, that's called pull. How we can do this? Okay, so maybe one of my team member, maybe I don't have my laptop right now where I have created this repository, but I have the internet access. So I go to internet from some of the laptops or working space, or maybe some cafe. I'll go here in my repository and log in, and I think there's some kind of critical issue come up in this file. So I click on this file. There's option here to edit. I edit this file and I write change by from GitHub. Okay, so I added some data here, and then I commit here in my master branch only. Okay, the change. So technically, according to GitHub, you have 3 commits. This is the last commit ID that GitHub know. All right, GitHub know. Only GitHub know. But this GitHub is a very different system altogether, and laptop is very different system altogether. Okay, in this at this point in time, if you ask to your local system, do you know, do you have any, we have some changes here? They say no. Okay, according to me, my branch is up to date with the master, okay, or the origin. But this is not true. This guy think the latest version we have is this one, 2 commits. But technically in my origin, some more commit we have done. Even though if you see this visual also, according to them, they are connected to the same 6B. But now Git origin is ahead. Your local system is one node or back. Okay, they are backward. Okay, with respect to Git, but local system doesn't know. Like I changed in my GitHub. And GitHub is a different system altogether in the cloud. My local system may be shut down. Or my local system doesn't sync automatically with them. So my point here is what I'm talking about. Okay, if you think sometime you work here, sometime you work here. Okay, in this case, if you think you do some changes in the GitHub, okay, or maybe some other developer of my team might change in the GitHub directly. So it is good practice when you start working in your local system. Okay, before you do some change in the local system, you start coding in some or changing some file, always go to GitHub and say, does you have changed something? If yes, just give me this information to me. Information to me. Now there are two things. Okay, you want only the information that something changed or not, or you want entire data with the information. Okay, so if you only need the information that something changed or not, if yes, what is a version ID or commit ID, how much change you have done. Okay, if you want this information, then we have a command called fetch. We can only fetch the information. But if you want no, I need the entire information and the data also, file source or content also, then you can use pull. Sometimes using pull directly is not good practice, because if you use pull, they will get the entire data to you, what a change they have done. But maybe in my local system, I don't want to have those changes right now. I don't want to update my local file accordingly. Okay, before I want to check something changed or not, then I can take a decision that I want to sync with the data of GitHub or not. Then we can accordingly use pull. Okay, so so what I'm going to do here, according to my local system, everything is clean. But what I do, I just use git pull command. So fetch command, you can use pull also, but for better way is to use fetch first. What fetch will do, okay, for example, right now, if you see your local file has only 2 lines. Okay, there's the data you have. But if you run the git fetch command, okay, you will see the difference also here. The first command, you're going to the same remote system that you connected. Okay, you're going to the system, same account or the same master branch. And what you fetch the master branch or the origin branch. Now if you see the status here, okay, now you see they say your branch is behind of the git master. Git master. We can see also here your local branch is at 6B and your master of GitHub is 4131. See here, 4131. It means you are behind. That's what they're talking about. You are 1 commit or 10 commits behind the original master. Okay, only this information come up, right? Because we're using fetch only giving you the information. Okay, but if you see the data in the local system, it is not yet updated. What data we are entering. But if you think you want to get data also, now you can use pull command. Pull. So pull will now get the data from the GitHub. Okay, so they're done. Get the data again. They're doing fast forwarding merge, means because GitHub is also like a different kind of branch, so their data merge in my local master branch, right? That's what they're showing you. Fast forward. Okay, and now in this case, everything is clean, up to date, right? And now your data come up. So depend, even though you can actually use pull also, pull will have both the capability, they get the info and the data at the same time. Okay, so mostly somebody will use pull a lot, but I recommend better first to use fetch, get the information, see what is happening. If you think that is what you wanted, then only you merge or pull the data in the local. That's what guys, the use of fetch and the pull we can use, right? This is a one thing. One more information here, let's say this is the repository I've created. And because while creating this repository, I make this repository public. So anybody who know my URL, they can download, even though without knowing my private key of SSH, they can download. Okay, in the local system. How? So here there's an option called code. In the code, they'll tell they will download by SSH, or maybe they can download by HTTPS also. Because in public, you don't need any kind of private key. So by knowing this URL, I just copy this URL and can download. In this case, the entire repository with data, all commit, my commit stream, my entire repository, all the staging area of these guys will copy to their system. So let's say this is one new system we have, and somebody want to work on this project. They come here and they can copy it. This kind of concept, let me copy in my other folder. Get WS workspace space. So how to copy? There's a command guys called git clone. That this is use of the clone. It look more like pull, but it's not pull. Pull instead of pull is clone. Clone means that we are copying the entire data from the scratch as a normal user of this code, right? But the pull, normally you use authentication, right? So maybe I have a data, okay, and in this project I know the login and password. I can also post. I know those authentication, something like this. So small difference, but you can think clone is something like anonymous. Anybody can come. If the public, they can clone and download it. Okay. So if I hit enter, they're cloning this entire project in my local laptop. All right, and they create a new folder here with the name of my repository, same folder they created. And if you go inside this folder, in your other systems, you can see the data will come up with the entire history, status, everything gonna come up with the entire information, even though they will also maintain the remote information also from where you are uploading. Now this guy will work here and they want to upload, they can push, but in this case, for pushing, they need login and password. If you know the login and password, my private key, then you can push, otherwise not. But you can still work on your local system. So clone is a very common command. Mostly you guys might know this command because in those who know Git and GitHub, this is one of the simple command mostly we always use. Okay, so this is one use of the clone command. Okay, now let me close this. Nothing very technical. This is one thing. One more a small thing, maybe that's what you know already, but I just show you one interesting concept. Not interesting, but useful concept, I can say. Okay. It will be something like this. I create a branch, get checkout here, and let me create a new branch called dev1. And dev1 branch, we change something in this file. Let's say d change we have done. We commit this. Dev1 committed. But this file, guys, this this branch is there locally only. You're on the gate status. This branch is committed, but because this branch is not there in my GitHub, so nobody's here track and nobody talking about the GitHub is one behind or you one ahead, something like this. So you do first always push git push and again set your upstream and say in the origin is GitHub, you want this branch to be synced with you. Okay, this is what the last command guy I showed you in my last class also. It's an origin. If this branch is not there, they will first create this branch. That's what they do. Then further they start tracking this branch. Okay. So now again they are up to date, but you're up to date with the GitHub. And if you see in the GitHub also, this new branch has been pushed recently, and you can see the name over the after refresh also. You will see there's two branches come up, and this is the details you have. You have. Okay. And what's actually idea? The idea is something like this. Okay, maybe somebody yeah, you have one project in the GitHub. This is the how it works. And somebody download this project, maybe let's say with a clone, they download in the local laptop. Okay. And when developers start working on the laptop, how they do, they create a new branch with the name of dev1. Okay. So they create dev1 branch to add a new feature, or maybe some of the open source project we have, somebody download the entire open source project rather than touching their project, because their project is there in the master branch. Okay, we create a new branch by, let's say, dev1 to add a new feature. After we added the new feature, okay, now we are not pretty sure. Okay, guys, this is very interesting use case. Now we are not pretty sure that what feature we added is perfectly or not. Should we add this feature on the master or not? Because this project is not created by us, is open source project created by somebody else. Okay, so what can we do? We will upload my dev1 branch to this project and ask them to create their one more branch with the same name dev1. So what a feature you added, it will update in the GitHub. So in their project, they already have the master branch, but now they have one more branch called dev1. You can see dev1 branch come up. And the guy who is maintaining this project in the GitHub, they will see and they check, the team will check what the code you added, DDD is working fine or not, right? They will check the entire thing. And if they think what are things you added is perfectly fine, okay, perfectly fine, so they can take the decision, okay, they can take the decision in the GitHub to merge your feature into the main project in the master branch. Okay, how they merge? So even though if you go to the master also, they're showing you here, okay, that there's one branch come up, is one commit ahead. Do you want to merge? I can say yes. This is what I show you. So there's somebody come from dev1 branch. I want to merge my base branch called master branch, right? And I will pull means check the difference. So there's some new one commit they added extra. Okay, so do you want to merge? So yes, I want to merge. Even though guys, even the merging also, we can do squashing also. You know what is squashing? I show you today. Okay, so this thing also we can do. But let me go for merge. But squashing also we can do directly here. The concept of squashing I explained to you already. I want to do merge. Okay, and do you want to merge? Confirm. I say yes. Okay, and now this team has got your data and put in the master branch, and for them this branch is not at all important for them, okay, because they already merged, so they can delete this branch. That is a very common scenario. That was this option you always see, delete, so they will delete this branch there. Okay, and finally they want to put comments, they want to put the comments over here. Okay, and if you see and go back, now we have only one branch. Okay, but in this branch, let's go master, we have up-to-date data, DDD. So technically, you know what I'm trying to say you? Okay, this circle, right? You download this project, maybe open source in a local system, you don't change directly here because you don't want in the management. You create your feature branch, changes here, you upload to this guy, to this team. Maybe they are your team only, okay, in your different branch. They look your data and they feel is good to go for merging, they merge here and they delete the branch there. Okay, or maybe they might do some small changes here while merging, because normally when you merge, mostly you have merge conflict that will be discussed tomorrow. You might have some conflict, there might some changes here before the merge in the master branch. So as the developer one, you want to again further want to go in your more feature in this project, so we again download this code from the master branch. Okay, how? So in this case, you will go in your local system, go back to the master branch. Okay, and if you see the status is clean, but I don't know, I'll go and search first, fetch my data. Okay, fetch my data from my GitHub. Okay, because technically maybe they have some extra commits. So this fetch will fetch the information. Okay, the fetch the information that something has been changed there. Then we show you are one behind. Because you're one behind, just go and get the pull and get the things. Okay, so now it's been pulled. And now this data has been updated in my local branch. Okay, so this data again come back to a local system. How? The updated one. Take from you only, but they might have to do some changes here because normally when merging, there are a lot of conflicts come up. Something to change before we merge. That's we'll talk. I will talk tomorrow, and then you will again download in the master branch so they can start working on it. But for working, this feature branch is not required because they already deleted. You also have to delete. So first you will get branch, delete your dev one. Okay, and again you get the same branch, other branch name, and start working. Same circle is keep on going on. So this is a way normally we contribute on the open source. Some more thing we have to again do, or this is the way normally we start keep on giving contributing the data, again getting the data back, again work, again we provide. Okay, so it's a some kind of cycle. We have some more discussion to be do here after you guys come to know merge conflicts. Simple topic, nothing very technical. We can do much more thing here. But this is one good idea we have created. This is how things work. I think you also understand the meaning of fetch and pull, push, clone, and some kind of branching concepts more, right? So that's all, guys, for today. Lots of information, guys, I throw here. Rather than only the command, main thing is rather than this focus more on the command, just try to understand very different use cases, scenarios, challenges, and this is what you start with. Then see if this challenge, what is the best way to manage the thing, and then accordingly to management of those things, what kind of commands you can use. So that was the better way to learn this concept, right? So that's it for today, right? Those who are in the DevOps training, we have next class on at 2 o'clock with Ansible. Again, very, very powerful different tool. Will catch you there, guys. And otherwise, those who are only in the GitHub, will see you tomorrow at 9 a.m. morning IST time, Indian Standard Time. Otherwise, any query if you have, you guys can ask. So I believe, guys, you guys asking today or maybe last class a lot of concepts about something. I think these expression help you to understand more clearly. So somebody asking me different way revert and reset. Revert, Yusuf, I haven't explained yet. Revert, I'll take very interesting command. More look like reset, but it's a very different scenario it's solved. So Yusuf, I will explain you about revert tomorrow. Reset we discussed already, but what is a revert? I will explain tomorrow. Then you can compare. Okay, rebase also I will explain tomorrow. Rebase concept. Okay. So I think, guys, this is the message is come from you guys, because the last topics give you a lot of information about what are the questions and query you had in first, second day, and maybe today morning. Stress also will talk tomorrow, right? Now, after having these much information, right, then completing the stress or revert or rebase won't take much time. So very quickly we can cover those concepts. Okay. So I'm just trying to. how to recover deleted, or Neil will talk a little bit about it maybe tomorrow, right? So for this, we can use some better practices use that I will talk. If you want, we'll talk tomorrow. When rebase is useful, that was topic of tomorrow again. Rebase. I'm talking about. Okay, right. Git Wiz. This tool is working almost in all the operating system, but you have to. They give a source code. You have to compile it. Okay, but by default they only give you, I think, exe file for Windows. But from wherever you download this exe file, they give a source code, download the code, most written in, I think, in Node or JavaScript. You can compile in respective operating system, then get Wiz work for you. Or tomorrow I'm going to give one more powerful tool, have more options and more things you can do. Okay, better than, not I can say compare better than, but have more facility. You can also use those tools that I'm going to introduce. I will introduce tomorrow. Okay. So is any way I can know for Grafana Prometheus? Badal, it is a part of DevOps training. I'm not really sure individual topic you can join, at least Grafana Prometheus, right? Jenkins you might join, or you can join as an individual topic in our DevOps track, Jenkins, right? But I'm not pretty sure about Grafana Prometheus right now. So some example how to work on a project on DevOps. So technically, Git Bash is just a tool where we are running the Git command. So there's one thing. Tomorrow I might try to give one idea, because for DevOps is a big world altogether. If you have a knowledge of Jenkins, then integrating with Git makes more sense. Technically, I can say. But even though Lingana, I'll try tomorrow to give some idea of hooks that you can use in Git or Git Bash to connect with your DevOps tool to automate something. So I will give that idea tomorrow how we can do it. So right now, the way I'm giving this information to you, how SM tool work, even though if you talk about today also, or in my last class, I just try to explain you how the thing work. There's a multiple node, every node connect to each other with called linked list, and every linked list are in the tree. So this is the ideas I'm trying to give you internally, plus some more internal concept, right? So if you know this idea, and if you know the concept of DSA, data structures, especially tree data structure or the linked list, right? You can build your own SCM tool. So obviously we can't build here our SCM tool. Okay, I can only guide you the internal concepts. Building obviously require a lot of knowledge in programming perspective, maybe C++ or maybe other language, mostly C++. So then only you can build. So we're not in this training of DSA and C++. But if you know these languages, if you know the data structure concept very clearly, right, then you can build it. But for building, you should know what and how Git working behind the scenes. That is the thing that I'm just keep on giving this information to you. Okay, even though if I don't tell this option how the tree connected, you can work on the Git. But my intention is to just tell you how the thing work, how the nodes connected. So if you know the DSA and the tree data structure, you can think and start creating your own HCM also, right? Depend what feature and facility you want to provide there. Okay, but maybe tomorrow I'll talk a little bit more about it to give more clarity. Those who wanted to create your own SCM tool, they will get further guidance in my tomorrow class. Cherry pick also is a topic we will discuss in Jitenshu tomorrow. Cherry pick. Uh, how to enroll for Jenkins course. So Madhu, you can contact to my team, or maybe maybe my team will update everyone, because we put, I think when we launch the Jenkins, soon we are planning to launch Jenkins, only Jenkins training as a separate training if anybody want to go only in Jenkins. So you update in your groups or maybe in our LinkedIn profiles or my company profiles, we'll update you how to log in, or how to enroll for Jenkins course. So, so what is mean by detached head node? uh, Detached head node, I think I explained you multiple times today, right? So when you do checkout, your head will go to one of the respective node, and that is called detached node. Or your node is unreachable or orphan node, and you connect to head, that is called detachable head node. Okay, because we remove the head. If you see the diagram, we remove the head pointing to the master branch. We are taking the head to some other orphan branch, that is that state, that time is called detachable head node. Okay, so that's all, guys. See you tomorrow or maybe in Ansible class. Bye. Good day and see you. Take care.